So to start the day, I would like to invite Dr. A.K. Srivastav sir to chair the session, and Sri Ranjan Phukon as a rapporteur of this session. Floor is yours, sir. Thank you very much.
Hello. Good morning, you all. So we are starting the session, the first session. The first presentation would be from Thailand, presentation of impact outlook developed for South Asian region at SASCOF-28. Mr. Saswat Avi, please. Time is for 25 minutes and we'll keep for 5 minutes. 20 minutes. 18 minutes you keep for presentation, 2 minutes for question answer.
Okay, sir.
Thank you. Please start.
Show something. Yeah. On Chrome, can you open that once it's saved?
Chrome probably is not there.
Can you open the notepad?
Here?
Tool. Copy it.
Okay, you can use it whenever you need it. But the screen will be visible, your username and password. When you open it here now, it will be visible to all.
That's what we want to log in first, so that I don't need to log in at the time.
It will be logged out automatically.
ये नीचे मल्टी इंडेक्स राजीव से बोला कि नीचे से मल्टी इंडेक्स इन आईटेम ये नीचे है ना वो वाला टॉप ऊपर होगा ठीक है
I'll not remember it. No, then this file should I delete or you can do it just before? You need separate to all file keeping pen drive here. We have some online participants also, so I'll share the screen. And then online participants will not be able to see properly.
There's some notes which I need to refer.
Okay, should I keep like this one?
Yeah. Check.
So they will be able to see only a screen like this one. And then again, you will be having the issue while showing this thing.
Can you check if it's visible like this?
Yeah, it's visible like this. But no issue. I think it's fine.
So the notes will also be visible to them.
Yeah. It will be visible to them.
Okay. One thing we can do is in the Zoom, the screen that we are sharing, can we go to that? Okay, have we duplicated the screen?
Yeah.
Okay, can we extend the screen and then show the second screen?
Here?
Yeah.
Windows P.
So it is extended. So where's the Zoom?
Yeah, this is the screen that they are able to see.
Okay, where's the Zoom window? Please check.
Good now.
You can bring me on this screen.
That's fine.
So if I move to the
Here,
next screen,
in Zoom is,
it doesn't go to Instagram. It's not
yeah, but when you're opening the browser, you have to change it again.
Okay.
You'll do it.
Yeah.
Thank you.
So is mic's active? Hello. Is mic? Audible? Hello. Hello, everyone. Very warm good morning to everyone. My name is Shashwat Avi. I'm a consultant data analyst at Disaster Risk Reduction Division at UNSCAP. So, first of all, I would like to apologize that I couldn't deliver the presentation yesterday. And thank you for making the arrangements to make the presentation today. So, I'm here to give the impact-based forecasting for the seasonal outlook JJS 2024. Moving forward, so SCAP has supported impact-based forecasting for a number of years. Impact-based forecasting allows us to understand not only what the weather will do, what the weather will be, but also what the weather will do. Our IBF methodology works by taking the hazard layer, such as the seasonal forecast data, and overlaying it with exposure and vulnerability data, such as population data, agriculture data, to calculate the likely impact of the forecast on socio-economic variables and specific sectors. SCAP's impact-based forecasting approach follows WMO's global framework for climate services and supports early warning systems and EWS for all. If we move to the next slide. Using the 100-year return period hazard map, drought frequency map, and the vegetation condition index, areas of concern for the above normal and below normal precipitation are identified. If we look at the VCI map, let me zoom in. So if we look at the VCI map, we can notice that for the Myanmar region, we have the vegetation health is very low. And if we look at the drought events map, we can notice that that event has, the area is also drought prone. And the seasonal forecast showing below normal precipitation in those regions makes it an area of attention. Similarly, we have some areas of for above normal precipitation, or we also have some areas of advantage. For example, the southern parts of India and Sri Lanka, the northern parts of Sri Lanka, we can notice here that they are drought prone originally. And if the season forecast shows above normal precipitation in those areas, okay. So if the season forecast shows above normal precipitation in those areas, it becomes an area of advantage in those conditions. Also, if we look at, I don't know how this works, but if again we look at the Pakistan region over here, the northern Pakistan region is actually drought flood prone. We can see that from the flood maps that is here, over here. So they are actually flood prone areas. And if we compare that with the SASCOF data set that we have, it shows above normal precipitation. And those areas also become an area of concern. But at the same time, if we look at the southeastern parts of Afghanistan and southwestern parts of Pakistan, those areas are actually drought prone, and a high likely of above normal precipitation actually seems to be a advantageous situation there. So we have marked those in light blue color. The boxes which are in dark blue color are areas of attention for the above normal precipitation. And similarly, the ones that are in orange are the areas with below normal, are the areas of attention with below normal precipitation. So this is a wider view of what we have. So these are the areas of attention that have been identified. Moving on to the population exposure, we can see, I don't know why this is happening. Okay, here we can notice that the population exposed to below normal precipitation, and we can notice that around more than 35% probability, only 3% of population is getting affected by the below normal precipitation. And if we move on to the above normal precipitation, we can notice that 73% of the population will be affected by the above normal precipitation. We have the graphs also showcasing for the different areas of countries of SASCOF, what will be the different varying percentage exposure that can be seen in the graphs below. Similarly, if we move to the next section, where in this section we have the HDI. Sorry, it's a bit slow. Let me go back. Okay, so here we have the HDI, and we have marked some of the areas of attention. In this, we can notice that some areas, for example, the northern and central parts of Pakistan, the HDI level is actually very low in these areas. And these areas have also become an area of attention. So that becomes an area of concern regarding considering the HDI as well. Also, some parts of the northern and northeastern parts of India and Nepal, those areas also show a very low HDI levels, and the SASCOF, the seasonal forecast also shows an area of concern there. So that also becomes an area of attention for the low HDI population there. And similarly, we have the Myanmar region, where that also becomes an area of attention. If we look at the agriculture production value, we can see that for the probability of 50 to 100% of above normal precipitation, 26.9% of the South Asia's agriculture value are likely to be exposed. In that, we can see that India's agriculture value of 27.5% are likely to be exposed, followed by Bangladesh at 32.7%, Pakistan at 27.6%, and Sri Lanka at 86.6%. Similarly, if we look at the agriculture value which is exposed to the 35 to 50% probability of above normal precipitation range, then the number goes to 44.5%. In this category, 47.2% of India's agriculture value are likely to be exposed, and followed by Pakistan, which is at 63.6%. In total, if we look at in total, 71.4% of South Asia's agriculture value are likely to be exposed to the above normal precipitation. Now, if we look at the below normal precipitation, for the below normal precipitation, we can see that 1.7% of South Asia's agriculture value are likely to be exposed to high probability of below normal precipitation. And in total, we can see that 4.8% of South Asia's agriculture value are likely to be exposed to below normal precipitation. From agriculture production value, let's move to the agriculture production quantity. And here also we can see a similar trend that we see for the agriculture production value. So moving on from agriculture, our next sector is the hydropower exposure. In this also we have overlaid the hydropower maps with the seasonal forecast map. And here we could see that for the below normal precipitation, 5.6% of the total hydropower plant's capacity are exposed to 35 to 63% probability of below normal precipitation. And most of them are located in Myanmar, India, and Pakistan. And similarly, for the above normal precipitation, we can see the 46% of total hydropower plants capacity in South Asia are likely to be exposed to 35 to 100% probability of above normal precipitation. So we can also notice from the graphs below the varying percentages of exposure in different countries. After this, I would like to just highlight the risk and resilience portal that we have developed. The driving force behind the portal is to support countries in Asia Pacific region effectively translate global climate models into actionable regional, transboundary, and of course national disasters and climate strategies. Our goal is to provide policymakers and stakeholders with a comprehensive tool to visualize how climate risk could affect the region's economic, social, and environment sectors, as well as their progress towards achieving the Sustainable Development Goals. Uh, Before looking at the specifics, I wanted to put this slide to show how the portal translates and digitizes scientific analysis in an easy-to-use manner. It is a science policy action interface with a state-of-art data-intensive analytic ecosystem. Using big data, AI, and machine learning, the portal integrates hazard, climate, social, economic, and economic sector data to become a one-stop shop for evidence-based decision-making by policymakers. Now, to take the impact-based forecasting into the digital arena, SCAP has been working on developing an automated impact-based forecasting tool, which will be able to process both hazard exposure layer by taking that exposure layer as input. This means that the user will be able to input their own forecast layers. The data format will be the data format has to have a certain requirements, that it has to be a raster file, and the values, the raster pixel should be have percentage values. But moving forward, just to have a show of how the tool works is we take the following inputs from the user: the population data, infrastructure data, the hazard data, and the boundary data. Then it goes through the three phases: the geospatial pre-processing, the process identification phase, then the geospatial exposure phase. In the geospatial pre-processing, we actually set the coordinate reference systems, we set the resolution and classify the hazards into different intensities. After this, we go to the second phase where this is process identification. In this, we auto-recognize what kind of infrastructure file or the population data that is. And according to the file type, we decide what is the process to calculate the exposure. And then with that exposure process identified, we do the geospatial exposure analysis. And once that is done, we get the output, which is in terms of interactive maps and charts and exportable tables. So you may be noticing that I was talking a bit in the future tense, but we have this automation tool ready. So I would like to go to the browser and showcase the tool. So let me open up the browser. Okay, so this is our risk and resilience portal. We can go into the risk and resilience analytics, and then we have the country tools. In the country tools, we have the data explorer section. Once we go here, we have added a functionality of sign in over here, where each user needs to sign in, so that we protect the data from being like the data that is uploaded by users shouldn't be used by others. So we go to the customize section from here. And in the customize section, we have the seasonal forecast here. We have the presets. If we pull this down, we have a drop down where we can see all the data sets that can be shown. For example, one second, let me just select this seasonal forecast. Okay. So here you can see that we have three sections here. We have these we call as the presets, where we select the boundary data. Boundary data currently are fixed. We can select only from these fixed boundary data sets. From that we can select any of these boundaries, and then we have data sets that are pre-uploaded, the past data for which the calculations have already been done. We can see the above normal, the below normal. And from here, once we have selected the data sets, we can visualize that on the map. So we have this map ready here. Apart from this, we can overlay this with population layer and change the different opacity of the seasonal forecast data. and increase the opacity of population data to have a more clear view of the population exposure. And similarly, we can do that for the population with low, medium HDI, the elder population, the female population, and also with infrastructure data like health facilities, e- education facilities, power plants, and so on. Apart from this facility, we also have we are giving the user the flexibility of uploading their own seasonal forecast data. So to do that, it's very easy. We have to just give it any name here. And then we can select the boundary file from here. And then just we have to upload the hazard file. So I have a hazard, the seasonal forecast 2024 data set over here. And I'll just upload this data and we can start the process. I'll just name it 1. So I'll just start the processing from here. So the file automatically gets uploaded and the processing is started. Now this generally takes around 4 to 5 minutes to do the processing. So I have actually done this. If you go to the data management section, we can see that this process is running here. And there is a functionality where we can set it public or private. Basically, if we want to make the results of this file public, we can definitely make it public, and any user that comes to this section will be able to see the results that are offered. So this is the same results that I had calculated yesterday. So I will just show you this. So once we click on that, so we can click on that. And we can see that the map, one second, let me deactivate some of the layers that are already there. Okay, so we can see that the 2024 season forecast map has been auto-generated. Now we can overlay this with the different exposure map layers. And if we go to the chart data, we can go here and we can also select the infrastructures that we want to see the exposure for. For example, if we want to see power plants capacity, then you can see here we get a top 10 countries and what are the exposure to different categories. Similarly, if we want to see this in more detail, we can go to the charts over here and we can see the details from here. Also, if you want to see this in tabular format, we can see the data in this format. This currently shows the values in percentages. We can also change that to absolute value, and we can see the absolute value as well. So for this exposure calculation, we have different infrastructures that we have: railways, highways, and airports. So apart from this, if we want to see the analysis and compare the analysis with the past year's report, we can what we can do is we can go to we have a compare section here. In the compare section, we can actually select, for example, the 2023 data set, which are available in the configure section. So we can select the 2023 above normal data set. And now we can compare how it is compared with the 2023 data set for above normal. And also here, again, we can put in different map layers. For example, in the right map, we can put in population. And in the left map, we can select from here and we can go to the left map. And in the left map also, we can put in some other indicator, like for example, the health facilities. And basically, this gives a very comprehensive way of looking at two data sets. We can compare the seasonal forecast from different organizations as well, like the SASCOF and the ASEAN-COF. So this is the very first version of the tool that we have developed. In the next version, we are also planning to give the user the flexibility of uploading their own boundary data and also the infrastructure data. The infrastructure data sets that are currently used, the sources for them can be found in the methodology section. but there is these restriction that we can the hazard data has to have only the percentage values. So these restriction can also be taken care of in the second version of this tool, where even if we upload seasonal forecast data with absolute values, those could also be processed, and users will have the flexibility of uploading their own infrastructure and boundary data, as I told you. Currently, the tool works on a national level, but if we provided data sets with high resolution, we can also go subnational with the tool. So, and apart from this, we are also working on a decision support system where we can click on any of these countries, for example, and we can dive deep into that country and decide what are the individual comparisons and also look at the climate adaptation portions of those in those areas as well. So,
2 minutes left.
so this was my time. Thank you. And here's the, so I'm open to questions. Please let me know if there's any questions. Yes.
Hello.
Yeah.
Dr. Shashwat.
Yeah.
I'm really happy that, very fantastic, tool. This. In fact, I was thinking that now you have been doing this last 3 years, helping us to prepare this one. I was thinking how this can be, used by other countries. Just before when you started the presentation, now that you have shown, I think we have got access to that. Anybody or registration has to be done.
So currently we will be rolling out and we'll be giving this tool to the users and giving them the authentication for that.
Yeah.
But currently it's in just the testing phase. We'll be giving it to different organizations. But once we are ready with some of the intricacies, actually yesterday we went into a technical solution, technical problem. That's why I had to postpone the presentation to today. But definitely it'll be very soon. It'll be available for public.
Yeah. So I find that boundaries. First my question was that now that you just later said you can have your own boundaries can be uploaded and get it prepared. So I think that a lot of our problems, next future. I think 3-4 years you have sorted out, because once now that we are preparing very nice forecast is coming out, outlook, the next stage should be how this can be applied. There should be some facility to country wise that they can prepare and that can be generated in their own country separately. So for national purpose that can be used. So I think with the boundary entry it will be. So my without going last question is that when you are going to train our people.
Sir, 100%. I'm available anytime, and we have also working on a e-learning module where we'll have a very detailed analysis how we do the IBF, and also we are working on a tool where we'll make it public how it is getting developed, and different Python and Python tools, which are actually Python libraries are also there, which are for GIS analytics. So making the public aware about those analytical tools. So definitely we'll be working on that as well.
Hello. Hello and good morning, everyone. Yes, sir. We also want to have access on this tool if it's possible, and we want to know that how it will use for seasonal forecast if it's possible.
So currently the tool, as I said, is on a staging platform, and we are 100% ready with the tool. It's just some formalities like the authentication and some portions are just go into some technical errors. So we are trying to give a finished and a fully polished product to the users. So we are taking some more days for that, but very soon we'll be rolling out the automation tool and it'll be available for public to utilize. Yes.
Okay, thank you.
Yep. Yes.
Yeah, the impacts that you are trying to work out are basically
Yes. Correct. So, okay. Right. So let me answer your question, sir. So, for example, some of the current analysis that we are doing, as I displayed, they are currently on a country level, for example, the national level, and we are not going into the subnational level. But when we go into the subnational level and develop these decision support systems, we'll be looking more into these details, and these factors will obviously be taken care of. So even to decide the adaptation, for example, these specific details will play a very important role. Going subnational, these factors will be taken care of. But since it's on a like a broader level, national level, so currently we are not focusing on that. We're just focusing on the seasonal forecast analysis. So
Yes.
I hope that
in future probably.
yeah, in future.
Yes.
So that definitely that's a phase 1 product that we have developed. In the phase 2, definitely all these factors will be taken care of, and the decision support system that will be on a country level will take into the account these factors that have been mentioned.
Yeah, just I have
Yes.
2-3 questions. First, regarding where your map, that flood hazard map, 100
Right.
years return period, how you have reached that 100 years return period of flood? You have taken actual flood occurrence, or the return period, 100 years return period, or simply extreme rainfall?
So actually, maybe you are talking about the
That
very
flood
first.
hazard map, 100 years return period.
Yes, sir.
How you have arrived that 100 years return period of what?
1 second.
Is
Let-
it
let me-
actual flood of data, or
So
only
the
precipitation data?
the data is directly available online.
No, I'm asking that flood hazard map, it can be real flood or extreme rainfall flood.
Extreme rainfall flood. Those
Yeah.
are flood events.
So because hazard, whenever it is going to vulnerability, if it will be better if you use actual data, that is flood data, because whenever extreme rainfall happening, it is not flood is not happening. So
Right.
there is some communication or means information passing or some misinformation, so it may affect your impact-based forecast.
Sir, let me clarify a bit myself, sir, here to answer your question. So this was the map where we used the flood hazard, the 100 years return period map. And on the left-hand side, you can see the drought events map. So these are basically the drought frequency maps, for example, where these have already occurred.
Again,
And-
I am asking
Yes.
actually about the drought, same thing, how you have used any index, drought index, or simply the less precipitation?
Sir, actually, these are decided. The data sets have there are data sets.
Okay, go through.
Yes,
This
sir.
is 2 questions you just listen. And then first already the price of the last 3 years, I'm saying that it is very good, but whether once implemented, I think if we present along with that, how it has been benefited by any country, if you have, because you are giving guidance that below rainfall, that some
Right.
feedback, it will be better in future, next SASCOF.
Definitely, sir.
That's right.
Sir, so basically, again, as I told that this is currently on a national level, but once we go subnational, then it'll be far better to get more detailed feedback, and countries would be
Okay. Then
really willing for that.
final one, because we are also giving this SASCOF for the temperature, just like cold wave and heat wave.
Right.
We have seen that you are using this. Basically, it is simple guidance, not actual impact. If you combine that, suppose you are overlaying different layer, population layer, that human comfort, development index like that, different layer, and giving the guidance. Instead of that, that is multi-hazard. Suppose some index, if you combine with some proper ratio, that one unit which relates, because suppose I'm telling heat wave, cold wave, or even flood. Suppose for cold wave, we know that one is cold wave vulnerability, then people with old age and people with this child rate. This type of two population as well as economy, means poverty level. 3, 4, if you combine then multi-index, and that will be actual index, it is not, it will be objective criteria. Here simply layer, overlaying the layer and giving general guidance. So instead of that, if you use that, along with prepare that for the heat and cold wave also, similar, not only rainfall, so it will be better, more useful for the health or other sectors also.
Yes, sir. Sir, so I totally, to answer that question, I totally agree with you, sir. For the exact analysis and for the exact exposure calculations that we are doing, we definitely need to take into account a lot of factors, not just the other sectors that we're working on, but to obviously give a general idea, the exposure IBF calculations that we are doing, actually they are following the approach that has been given to us by the WMO's global framework for climate services. So we are following that approach. But again, these approaches that we follow, these are not 100% accurate exposure calculations. But those will require a lot of analysis, obviously taking into account in what probability which factor affects. So so those factors we right.
I think we should stop the discussion. We can.
Sure,
This is-
sure, sir. Definitely looking forward to that.
What I say, this is a very good attempt. Still in beginning stage. Lot of things are to be done yet. One simple, just I wanted to, you see, we have given so many options of data set. Suppose we are using SASCOF data and you are using FOCRA data.
Okay.
But two contradictory scenarios are coming. Probably, you see, I have seen this FOCRAs that I personally attended, and we have, sometimes forecast differ quite a lot.
Right, sir. 100%.
So two contrary situations may arise if you use the two data set, and it will be very difficult for a decision making or planners. It's my simple comment. Probably sometimes we may get some sort of information or contrary information.
Right. So what we developed the compare system, compare tool, added that feature in the tool just for getting an idea of this as well. Because rather than looking at the differences, we focus more on what are the similarities. So that gives us a better idea that this has been approved by both the things.
That is another way, another way of thinking.
So looking at the brighter side of it.
Yes. But a lot of things are, of course, always what Dr. Rupkumar told, that a lot of things are to be done. Anyway, it's a good beginning. Thank you,
Yes,
Mr. Saswat, for a nice presentation.
Thank you so much. Yes, sir. Please. The tool?
So generally in impact-based forecasting, you will have low, medium, and high. So did you do that kind of analysis or not yet?
Yes. So actually, let me go back to the slides. Then let me go to the last part. 1 second. It's slow. Sorry. Right. So here, as you can see, in the geospatial pre-processing phase of the automation tool, actually the seasonal forecast data that is there, that is divided into different categories. So those categories are based on the intensities. So as you had to.
So if this is the case, then I have a question. For example, the seasonal forecast that we are doing may impact agriculture more than the health.
Right.
right? So do we do the impact-based forecasting for every sector, or it is all one, or how that works?
So how it works is once we upload the hazard data, all the infrastructure data that are already there on the portal, for all of those infrastructure data and population data, the exposure is calculated once and for all. And once those are calculated, then the user has the flexibility to go to the online tool, and then we can visualize it using the chart section and using the maps. And we can also look at, we can also compare the data sets. So that's the basically advantage of the tool, that earlier for each of these infrastructure or population calculations, at least 20 hours of professional human time was needed.
20 hours?
Yep, that's what was done at our institute. And then it was noticed that we are just repeating that same process for each of these infrastructures, and a lot of time is getting consumed. So our basic idea before for developing this tool was to first of all make this redundant activity into a automated tool where we just upload the hazard layer every time a seasonal forecast data is getting uploaded. It can directly be uploaded to the server, and all the exposure calculations can be done at once. So that was the motivation behind developing the tool. Yes.
All combined, all the exposure combined, then like if the higher impact on one sector might be lost, right? So is it good to have sector-wise or exposure-wise impact, or how? What do you suggest for us if you wanted to do?
Okay. So again, when I say that all of them are getting calculated at the same time, I mean for each of the infrastructure it gets calculated one at a time, but all of them has to be done. All of them are done, but the classification for the hazard is done like for example how you said it is low, medium, high, then the different classifications that are done. So for each of those sections, for each of those classification, what is the exposure to each of the hazard? So all those in detail is provided on the online tool. For example, if I just take you to one of the results. So for example, if we go to the table section over here, we can see that the 35 to 40 category, what is the exposure? And similarly, for each of the categories, we can see the exposure values. Let me come out of this compare view. One second. Okay, so for each of the categories we have for health facilities, for example, and similarly, if we go to the education facilities as well, then again, you will find the same categories over here as well. So 35 to 40% probability category is considered very low over here. So for each of them, we can find the classification for each of them, for each of the exposure calculation for each hazard and infrastructure type. The calculation is done for each of the classes. So that's, and the view currently shows the values in percentages. We can also see it in numbers as well, the absolute numbers as well.
I think Mr. Saswat, please stop. We may
Yes,
discuss
definitely,
in
sir.
between. Okay.
I
Thank
hope
you.
I answered your question, ma'am. Thank you so much.
Let us thank Mr. Saswat. Thank you very much for a very nice and excellent presentation. The next presentation would be by Dr. Ashok Kumar Das from IMD. He would present on the topic South Asia flash flood guidance system. Das, your time is for 20 minutes.
Cursor is on that screen. You have to take it left. You have to move it left. You have to move it left. It will come out from here. Okay, 1 second.
It's coming.
Okay, right. Slideshow. Okay, can you just close that file? The two files. Okay, take the pen drive. Thank you so much.
Yes. Good morning. I'll speak on South Asia Plus Flood Guidance System, which is operational in IMD. As you know, Plus Flood is a very fast disaster event. The time between occurrence of the rainfall event and its peak discharge is less than 6 hours. And its main cause is heavy rainfall in a short duration. And last 2 days, many of us have mentioned that due to global warming, the frequency of heavy rainfall events are increasing. So consequently, the flash flood events also increasing. To mitigate this and to minimize the loss of life and property, Meteorological Department, in collaboration with WMO, jointly implemented the project South Asia Flash Flood Guidance and provides flash flood advisories operationally to NMHS centers in Nepal, Bhutan, Bangladesh, Sri Lanka, and India since October 2020. IMD-MOS is designated as the regional center for South Asia for catering the flash flood guidance services. Presently, IMD provides location-specific flash flood guidance advisory up to 4 times a day, and there are more than 1 lakh water sets for which we are providing the operational services. These services mainly in the form of threat and risk. Threat, which lead time is for 6 hours, which is based on real-time observation data like radar, satellite, gauge, hydrological data, and risk is valid for the 12, 24, and 36 hour, and it is basically based on numerical weather prediction model. This is the view of the FAGS console. Some diagnostic product is there, warning products is there. The diagnostic products includes radar precipitation, microwave adjusted global hydro estimator, then GHE, gauge map, March map, ASM soil moisture, this is ASM soil moisture, then FFG. These are all the diagnostic products. These products are available for hourly, 3 hourly, 6 hourly, and 24 hourly also. And these warning products are basically in the form of IFT and PFFT, imminent flash flood threat and persistent flash flood threat. Now, the system is customized by 4 numerical weather prediction models, GFS 12 kilometer, NCOM 4 kilometer, and WRF 3 kilometer. All these 3 models are customized to the system, and the various prognostic precipitation products are generated. There may be precipitation, forecasted rainfall, mean aerial precipitation, then triple FT, that is forecasted flash flood threat, flash flood warning. all the three models, this type of products are generated on real-time basis. This is the view of the map server interface. The forecaster can select the dates, time at which it is running, and also he can select the various parameters like MWGHE, GHE, FFG, all the parameters he can select from this interface. And also there is some additional GIS layer customized into the system, like for the India district boundary, state boundary, mid subdivision boundaries are customized into the system. This is the various type of products, diagnostic products. It is included already, I told. MWGHE, this is non-NSDS microwave adjusted global hydro estimator, satellite based, CMOR precipitation estimates. Then GHE, this is global hydro estimator, satellite cloud top bright based temperature based precipitation estimates. GMAP, this gives mean aerial precipitation. In this respect, I want to mention here about for the country, India, we have customized our 5,000 rain gauge stations which are under DRMS, that is customized into the system. Then ASM, the mean aerial soil moisture, average soil moisture. These products are available hourly, 3 hourly, and 6 hourly. Then FFG products, this is the model generated products. FFG is the flash flood guidance value, that is every hourly, 3 hourly, and 6 hourly it is generated. This is the flash flood guidance value. I will come what is this flash flood guidance value afterward. Then imminent flash flood threat, persistent flash flood threat, all these values are available hourly, 3 hourly, and 6 hourly basis. Now the forecast products, WRF, NCAM, and GFS, the model precipitation, forecasted mean aerial precipitation, forecast flash flood threat, and flash flood risk. All these products are available in the system. Now the real-time dashboard, we can check dynamically what is the status of the data update, whether the data is updated in the system or not. That is in the real time we can check before analyzing the system. Now what is ASM? This is average soil moisture. This is a dimensionless quantity, which is the ratio, the contents over capacity. And for this ASM is computed for each water sets based on SAC SMA model. So saturation of the upper zone is very important for flash floods, because if rainfall continues, most of the rainfall will become surface runoff. This ASM also computed, the model is run for 0, 6, 12, 18 UTC. So ASM is generated every 6 hourly, and temporal variation is quite rapid depending on precipitation, intensity, and duration. Now the very important parameter, this is the flash flood guidance. What is the flash flood guidance? As the amount of actual rainfall of a given duration, that is just enough to cause bankful flow at the outlet of the catchment. And flash flood guidance then is an index that indicates how much rainfall is needed to overcome soil, channel, storage capacities and to cause minimal flooding in the basin. This is also generated on 0, 6, 12 ETC based when the model is updating. And every hourly, 3 hourly, 6 hourly data is available. If you see the figure here, if the soil ASM can be understood very clearly, this is the water level. This is the figure if you see, this is the water level, current water level, and this is the stage of the bankful stage. And this amount is defined as the FFG value. This much minimum amount is required for the flash flood to occur. Now, there is an inverse relationship between the flash flood occurrence and the FFG value. When the FFG value is very less, then there is a high chance for occurrence of flash flood. So the forecaster should be very careful when using this FFG value. Lower the FFG, higher is the possibility of occurrence of flash floods. Now, the another term is the FFT, flash flood threat. It is the amount of rainfall of a given duration in excess of the corresponding flash flood guidance value. Whatever the amount of rainfall is required to occur the flash flood. This is the excess of this FFG value. Like FFT also generates hourly, 3 hourly, and 6 hourly. The threat is 3 types of threats generated in the model: imminent flash flood threat, persistent flash flood threat, and forecasted flash flood threat. One by one, I will describe. This imminent flash flood threat is the difference of the merged map of the current scenario and the corresponding past model performance hour of FFG value. Previously, suppose we are analyzing at 06 UTC data, then we have to take the FFG. It will take the FFG value of the previous 0 UTC data and current merged map data, and this will give the imminent flash flood threat. That is it is just happening or just to happen. This is this imminent flash flood threat. It presents this. It should be noted that this product concerns the past rainfall should be evaluated and before using the warning. And each IFFT is valid for hourly, 3 hourly, and 6 hourly. And this is the persistent flash flood threat. This is the difference of recent persistence flash flood threat and corresponding current FFG value. IFFT, we consider the previous FFG value. Now PFFT, we will consider the current FFG value. This is the concept is coming from the previous precipitation of a given duration will persist for the same duration into the future. The past rainfall which was happened, we assume that this same rainfall will continue for the next 6 hours. Then this persistence flood threat products is generated based on this assumption. This is also generated for hourly, 3 hourly, 6 hourly basis based on 0 UTC, 6 UTC, and 12 UTC, 18 UTC data. And this alert is also, we are providing alert in 3 categories: low possibility, moderate possibility, and high possibility. I will come to the bulletin where I will mention there. Then forecasted flash flood threat. This is purely based on numerical weather prediction model, the difference of the FMAP and corresponding FFG value. This is also generated based on 0 UTC, 6 UTC, 12 UTC, and 18 UTC. And forecasters should note that flash flood threat itself is not a flash flood warning. Product just a guide to forecaster using flash flood guidance system, product and hydrometeorological analysis to make him to take decision whether he will issue the watches or warnings. Now this is the flash flood FF risk maps. The 9 prognostic products based on 3 models are available. The flash flood risk products, already I told, this is purely model-based rainfall forecast. That product is available for 12 hours, 24 hours, 36 hours. The quality of this product depends critically on the reliability of the rainfall forecast throughout the lead time interval. Now this is the use of the operational environment. Simultaneously, we can check the 4 products, the model products, maybe the diagnostic or prognostic product we can keep here and we can analyze. Now, for each watershed, there is a graphical we can check the real-time scenario. This is the red line is the FFG value, then green line is the ASM, and the blue line is the MAP, mean aerial precipitation. If you see initially, the FFG value is very high, and then soil moisture is very low. When the rain started, the soil moisture is increasing and FFG is decreasing. When the MAP is crossing the FFG value, then there is a chance of flash floods. Now, this is the operational system in our center. The National Meteorological Services, that is IMD, will provide the weather forecast and alerts, rainfall forecast to both National Hydrological Services, that is our Central Water Commission, and this forecast also come to, we will take consideration to our FFGS center, and also the model products what are generated in the system. Both the Central Water Commission, they issue the water level alerts and stream flow forecast. Then all those things are analyzed and issue the flash flood bulletins and share with disaster managers. These are the some forecaster checklist. Every during the flood season, when there is a chance of heavy rainfall, that time we interact with colleagues, teams through VC and checks every 6 hourly. For this, these are the checklist like synoptic condition. What is the synoptic condition? The near real-time model forecast, then satellite-based rainfall products, then meteorological warnings. What are the meteorological warnings are issued? LWP-based products, and then various type of hydrological parameters model generated, that is FFJ system generated, then prognostic products, and all these products are checked by the forecaster and issue the bulletin. This is the form of the bulletin, national, and this is for the Southeast and other countries. National bulletin, we are issuing 4 times a day based on 0, 6, 12, 8, and 24 EDC, 18 EDC data, which contains the area of concern, which area is concerning the occurrence of the flash flood, that we mention first. Then diagnostic, what is the diagnostic situation? What is the maximum rainfall for 6 hour, 24-hour data maximum rainfall in the concerned area of concerned area, that is we mention here. And the concerned, what is the soil moisture condition, that is also mentioned. Then prognostic products, that includes the model-based, what is the maximum rainfall over the concerned areas. And then it include the IFFT, and along with the alert, moderate, low, moderate, or high, that is also will mention. And along with the map, the model generated map also will include. Similarly, for the South Asian countries also, we are using the bulletin. These are the areas. As you know, this flash flood event is very rapid and fast event. So for this, the bulletin, we have tried to make it more faster, to automate that bulletin. Some of the portions we have automated, like time of issue, area of concern, and then what is the maximum rainfall observed, then model-based and soil moisture. All these areas we have automated, and also the maps we initially we download it and then kept in a folder that automatically the bulletin will take. This is the dissemination system. The automatic email alert is sending to the website, auto backup on the server, and updates on the social media. We have WhatsApp group. We share the bulletins in the WhatsApp group.
2 minutes to remaining.
Just a minute. They are the stakeholders, central in our country, Central Water Commission, then NMHS in Nepal, Bhutan, Sri Lanka, Bangladesh, and our flood met offices, regional centers, district met centers, all these our stakeholders. And this is my concluding remarks. South Asia FFGs generated threats and risk indices for evolving flash flood condition with significant success, thereby reducing the disaster impact. Integration of additional gauges, Doppler weather radars. Presently, we have integrated 18 Doppler weather radars into the system, and other radars also we are integrating into the system. It is in process. Then data sharing, it will actually more number of observation will go to the system. It will improve the system. So we are in process on this. Data sharing and event verification mechanism, continuous capacity building amongst the NMHS needs to be strengthened. And integration of socio-economic and exposure layers would lead to an impact-based comprehensive early warning system for disaster mitigation. Also, the integration with the CAP is also pivotal for the quick dissemination of alerts. Thank you.
Any question?
Thank you, Dr. Asad.
This
flash flood guidance system started from 2020.
Yes.
Okay. And we have seen that basically FFTs are diagnostic based on your satellite and radar estimate of rainfall.
Yes.
And we know a lot of biases are there.
Yes.
Okay. And let me continue. So we have already 4-year cross. Is there any verification because with the actual flash flood done?
Yes, sir. Event-wise, we have done some verification.
Not event-wise. See, event-wise,
Yes.
it should be uniformly based on 3 years or 4 years your guidance. And whenever we are having a lot of AWS, ARG or SRRG data for Indian region at least.
Actually, flash flood threat, we are verifying. Just suppose IFFT, I told the event occurred, IFFT. And
No. Again, see, whenever you are selecting particular event, simply showing the performance, we are not knowing the when it is missed that. It
Yes.
should be uniform based on 4-year data, whatever our AWS, our network is there, actual hourly data, and based on this full report with limitation, what is the error, what is the skill of that. Event-wise, particularly one event showing we have given good forecast, it has worked. That is not the proper verification.
yes, sir, I'm telling you.
Because radar estimate or always it is
Yes, sir.
bias is there, particularly heavy
Yes, sir.
rainfall.
Yes, sir. Definitely verification is very much important, but the problem is data availability.
No.
Whether the
We have
event
a lot of AWS, ARG data.
No,
particularly
flash
that-
flood event, occurrence of flash flood event, we'll compare with this. The
Then we
occurrence of
don't
the
know
event.
that 4 years over whether it is skill is there or not. And
Yeah.
we are giving this flat flood guidance.
Yes, we are working on it. We are taking that IFFT as the observation and the PFF, previous PFF.
That is also, with data is not actual, that is the estimation. Radar or satellite estimation, there is bias is there in there itself, and particularly heavy rainfall.
We have to compare the
You have
flash
to
flood.
ground gauge data or AWS, ARG or gauge data, then only verification can be done.
No, sir. Flash flood,
Proper verification system should be there.
yes.
No verification system.
There it should be. Any other question? Only actually what I saw some of bulletins from 21 or so. Okay, Ashok, I wanted just anytime they say recently we had a lot of floods a flash flood in Himachal or in 2 years back in
Yes, sir. Event wise, we have.
whether we are able to we issued warning well
Yes,
in
sir.
advance.
Yes, sir. Sometimes we have missed, but maximum time we have success.
But that you see what you are telling sometimes it should be some objectively okay 67% events we have covered or some
Yes, sir.
objective.
Yes, sir. We are working on it, sir.
Okay. Yeah, I think okay. Let us thank Dr. Ashok Das for a very, of course, but what Dr. Fuller told that those things are to be incorporated. But let us thank Dr. Ashok for a nice presentation. Thank you. Now I invite Dr. Rajiv Chattopadhyay. He will present multi-indexing drought monitoring in India. 20 minutes, Dr.
So first of all, I thank organizers for giving me this chance to present our group's work. So I represent Climate Application and User Interface Group in IMD Pune. Basically, our work is to use climate data and apply it to different sector-specific applications where stakeholders are more important. Now, we have a lot of different products, but today I am focusing on the drought monitoring in India, which is actually a very, for the upcoming monsoon season or the past season, it has become a very hot topic of debate, you can say. Now, in the IPCC AR6 report, If you see, there is a popular paradigm going on: dry goes drier and wet goes wetter. In the IPCC AR6 report, this has been little debated. So I have some statistics here which I have not put here, which says that if we have arid regions, it is showing a 38.4% of the area is drying. So dry goes drier. But arid region, 2.9% is going wetter. Okay. Similarly, for humid region, it's 16.3% is going drier and 8.1% is wetter. So overall, such statistics indicate that even a dry region can get drier, a humid region gets also drier, or dry region gets wetter and humid. So why I am bringing this paradigm is that, so it indicates a change, shift in, and we all know because of extreme event precipitation. So mostly droughts are based on precipitation and evapotranspiration factors. So it's so how do we, so like last presentation was on flash flood, it was a very fast onset disaster. Drought is a slow onset disaster, and monitoring is one of the best way to tackle its adverse impact. So at the IMD Pune, our group is doing work on that. So basically, there are, since this is a slow onset, I will not discuss about flash drought, for example, which is nowadays talked about in academic literature. Still, it's our traditional definition is a extended period of a month or so, or season. Okay, so so one thing is very clear, that there is a meteorological drought, which means deficiency in the precipitation, and its results in impact of agricultural drought or hydrological drought. Now, it may not be always, may not always cascade to another, because we have irrigation and all other processes which may not cascade, but some way meteorological drought can be assumed to be one of the important parameters for monitoring. So, so there are different factors. This is physical factors, like we have rainfall, soil moisture, surface water availability, depth of groundwater. Then biological factors, vegetation cover and composition, crop yield, condition of domestic animals, pests, etc. And social indicators, which are like food availability, land use conditions, and migration of population. So in all these cases, what what we are actually sector impact is on the agricultural need, drinking water supply, and storage of reservoir or groundwater. So as I told, that meteorological droughts are actually, which we are actually having a combination of precipitation and high evapotranspiration, and it is expressed solely on the basis of degree of dryness in comparison to some expected value, which are climatological expected value over a wide area or monthly seasonal time scale. Then we have the agricultural drought, which is basically which is basically deficiency or estimate of a soil moisture drought. And agriculture, crops, and natural vegetation, these are actually frequently associated with agricultural drought. Now, again, I'm coming to IPCC, and it says that nearly half of the population in the planet are going to face some form of water scarcity in a future scenario. So again, it comes that this and this water scarcity may not be on the agricultural scale, but it can be on the agricultural drought, it can be on the socioeconomic and other conditions. So so like hydrological, in case stream flows dries out, so we can have, we will have more reservoirs to store water, but however, due to rainfall deficiency, we cannot release enough water. So in the downstream, the river dries out. So in such different situations, actually, it is often a multiple and competing purpose. So the purpose when a disaster becomes a long duration, it cascades to multi-hazard type of scenario. So basically, when we are monitoring drought, it has to take into account if in a future where we have to include the disasters on a regional scale, local scale, at a longer duration. So finally, it comes to the socioeconomic conditions, because at the end, it is energy, food, drinking water, all are threatened by all this type of agricultural, meteorological, or hydrologic conditions. And this deficit of water actually is a risk. So in the IPCC, the risk assessment has been done very thoroughly, and it has been found that in such situations, there are a lot of damages to multi-hazard system, which is actually forewarned actually in a future warming scenario. So thus comes the applications to vulnerability analysis. So drought and the vulnerability to drought both goes hand to hand. So in IMD, what we do is, as per WMO guide, so first we tried to, we started with a standardized precipitation index, which is one of the WMO, so it is a deficit precipitation is the first order thing. So it has impacts on groundwater reservoir storage, snowpack, stream flow, and other things. So the Mackey et al. Paper in 1993 is one of the earliest paper, which, so this index is, this is precipitation is more measured all over globally, and more realistic, robust data is available for precipitation. So it's actually the best way to start with, and it was been suggested by WM also. So what we, but then we found that it has to be, or actually literature suggested that precipitation and evapotranspiration, the balance E minus P, is a more better estimate of actual surface water availability and other relevant situations. So standardized precipitation, evaporation, transpiration. One more index IMD defined in-house long back in the 1960s, even when this SPI or SPEI were not developed. It's the aridity anomaly index, which is based on, again, potential evapotranspiration. So this index is because of historical reasons and also otherwise, we find that this index is also very useful. So basically, we are preparing aridity anomaly index, standardized precipitation index, and the SPEI, precipitation evaporator index, for all this. So these products which we are developing are updated weekly, and it is updated every Thursday, Friday in our website. So if you go to our website, you'll find this suite of products which are actually, these are the aridity anomaly index, and then this is SPI. So we have products from aridity anomaly products are defined weekly, bi-weekly to monthly, and also some outlook is given. And then we got the SPI based products, which are actually, again, we have this thing. So there are, IMD give issues forecast in the weather scale based on GFS, and the extended range forecast is available weekly. So we use this forecasted rainfall to compute the future outlook for the up to next 1 week. And we also track season-wise, like monsoon season, post-monsoon season, or summer season also. And those maps are given, it could not be given below. There are other points, so we actually put a seasonal, how the season perform, the index power shows in terms of actual SPI or SPEI values. So as I said, that this is the computation. So the classification we have taken as the standard. When it is greater than 2, it's extremely wet, and less than -2 is extremely dry. Now sometimes, and near normal, moderately, sometimes Physically interpreting a multi-class type of system is very difficult. Sometimes we put simple three categories. Also, we clustered the nearby categories as one, and then three category also we give, like because we find that interpreting a multi-category product to stakeholders whom we get phone sometimes is difficult. That what is the difference between moderately wet and near normal and moderately dry? In terms of impact-based forecasting, is difficult. So we sometimes give that this is extreme and dry and wet is useful, but how we to interpret those type of scenarios for user. So it requires some more improvement, but we normally do it tri-category. Sometimes we also give. So this is the example which we show some of the products. So this is the latest products which are uploaded in our website. And these are all GIS based product, but so if we go here, we'll get the actual values in this thing. So this is the latest last 4 weeks. So we are going into the weekly products because the forecast, extended range forecast, is available weekly, updated. So we use that forecast product to give a so also we give like a 4-month SPI, which is we can see here. So these products actually shows, if you see the red color here or here, last 1 month or last 4 months, it shows very, in terms of precipitation, this is dry. So in the southern part of India, which we are having excess deficiency in SPI. Now, one interesting question is, can this be related to extreme water shortage which we are getting? Actually, so this naturally transforms this question from meteorological drought to hydrological drought, because whether it's a groundwater depletion or whether, so yes, we can give a first order idea in a long term accumulated cases, but the main point is we have to use river, for example, river water storage data, live water storage data, so which we are working on it, but we have not actually operationalized it. But to some extent, from the meteorological point of view, this highlights the current season situation in the last 3-4 months actually. As I said that we provide statewide summary also for the districts which are moderately dry and severely dry. So like this is a long list. It can be downloaded from our website. So we do this for every month, and we do this for a season as a whole, so that it gives a idea that which district has more water scarcity and more drought type of conditions based on SPI. So this is an example. This is the current condition as it was shown, and this is the forecast in the next. So this is a sliding window, we call it. So like a 4 weeks, this is up to 4 weeks. Then in the forecast, we take next 1 week advance. So we slide the window, forecast window, by 4 weeks as a 1 month, because SPI below monthly is not recommended by WMO. So what we do is a 4 weeks of the present, and we slide 1 week, in which the last week we put the value of the forecasted rainfall from extended range or GFS we put, and then we can get the estimate of the 1 week slide window. So this is also updated. So this is the monitoring, and we give it a outlook. And this is how every week these products are generated, and we are actually giving this thing. So as I said, we realized that the role of surface temperature, because surface temperature is measuring the evapotranspiration. So basically, SPEI is another product which is more realistic. In fact, when precipitation dominates, then the SPEI and SPI become very similar. But the situations when evapotranspiration dominates because of very high temperature, both differ. In fact, studies show that only 35% similarity between these two. So there are many regions where the SPI, SPEI does not. Now, in such situation, when there is a high temperature, for example, and so why I am bringing this point, if you see the seasonal forecast of the SASCOF region, and we compute the SPI, and if we see include the temperature, because temperature is also, both will give a different result if we calculate, because temperature is also going to be very high, which will lead to strong evapotranspiration, and precipitation is also going to be high. So SPI based estimate and SPEI based estimate would be different. So in terms of impact, I think both these indices has to be covered, and we monitor it in IMD, and so this is the SPEI, and you can see where there is rainfall, both these things, blue spots are actually having similar. So when rainfall dominates, it becomes, but in the other portions, many other portions, these deficient droughts are not matching. Similarly, we are giving outlook. So as you can see, this outlook is also next 1 week. So sliding 1 week window outlook, this gives a estimate how SPI is going to look. And the third product is the aridity anomaly index, which I said it has been developed much before SPI, and it is also one of a very reliable indicator of agricultural drought, because it takes into estimates of soil moisture conditions. So it is defined in terms of potential evapotranspiration by actual evapotranspiration. So in terms of this index, actually there are categories defined like mild, moderate, and severe intensity. So and the index is calculated, and intensity of agricultural drought can be predicted. So for example, if you see and this is, for example, this is 1 week. Now there is one good thing about this is that it can be computed weekly. Like SPI is not below a month, is not recommended. This aridity is a weekly, bi-weekly, monthly. In all the scale, it can be computed. And so we give this is, for example, this is weekly product, then bi-weekly product, and also we give the outlook of this thing. And as you can see, in terms of availability of soil moisture and other things, so this situation is a little different than what we have seen in the SPI or SPEI basis. So why I am telling this thing is that, so it shows that monitoring drought or water deficiency has to be performed based on multi-index indicators. Now, there are studies which actually shows or recommends actually monitoring such long-term things based on multiple index pulled together, like we can have some grading of arranging from ascending order to descending order. Then we put where the three indices are actually coincides to give some assessment of the vulnerability. But we did some experiment, but we are not putting it in operational sense. So multiple index-based drought monitoring is one of the product which can be used to give district-wise information. And please note that these informations are computed all on the district scale. So we are giving the bulletins, generating bulletins every week on the district scale, and then we are actually giving emails to the users. And if users want to get this email, please let us know that it can be generated, it can be sent to the user.
Please conclude.
The final slide here, I am talking about drought hazard and vulnerability, because in terms of vulnerability, is that the drought is a slow onset extreme event, and it's going to be affecting every country and every way. So we slowly need to move with socioeconomic data although here what we are showing is we have shown IMD has defined a vulnerability atlas where some of the natural disasters, most of the natural disasters are actually kept there, and based on last 50 years data, those disasters are seen and how vulnerable it is, which are the districts which are more vulnerable. It has been Dr. Pulak Sahab has taken the lead role in this before he retired from IMD. So this index actually gives what are the districts which are highly vulnerable in this case. So for example, this I'm showing only based on SPI based vulnerability. It can be done for SPI or it can be done for multi-index based also. So the vulnerability map will show which are the districts which are highly vulnerable and this can be generated. This is based on past data. It can be generated based on, for example, CMIP6 data also. So one important thing is that we have to use socioeconomic data also along this side to get a more like agricultural production, level of water in the dams and other things, so as to give a more meaningful diagnosis of this information. So we are working on it. And hopefully if the agricultural or other socioeconomic vulnerability information is available on a real time, this information can also be updated on a real time basis. So at the end, I just want to say that this multiple index, we are not clubbing together so far, but this multiple index based vulnerability analysis, in fact, we find it is useful. For example, in the dry season, SPEI is a very good indicator of water stress over different regions, especially 4-month SPEI is a very good indicator of the last season's water availability. And in the monsoon season, we are also giving although we are giving, so AI and the SPI are also very good in this regard. So we are going to a multi-index monitoring, and these products are also uploaded in the Twitter and our websites regularly, Twitter account of the IMD CRS Pune. So the take-home message is for operational monitoring, these products are very much useful, and it can be used if any stakeholder wants to use. We'll be happy to collaborate, and we can want to get the data of socioeconomic loss and damage data also, so that it can be made much more useful. So thank you very much.
Any question or suggestion?
Hello?
Yes.
I have one question. In the SPI, we should have the data, observation data from 20 up to 30 years data. And here we see for 4 weeks, you are adding 4-week data with the yearly data. Or how is your procedure? You are adding the data from 20 up to 30 or for 4 weeks?
So this is cumulated for 4 weeks. And we also have the same corresponding 4 weeks data in the past 30 years.
This is my question is that this is just 4 weeks data?
No, I mean in the real-time base. So we have the data, historical period data, for example, from 1971 to 2020. We have 50 years data actually. So as per WMO recommendation, minimum 30 years data is required. So we have 50 years data, weekly data. And for the current week, for the last 4 weeks, we have a rainfall data, for example. And then we feed this last 4 weeks data into that historical data which we have and decide which category it is there.
Okay, thank you.
Okay.
डॉक्टर साहब आपसे ये कहना है कि जो प्रोडक्ट्स आपने बोला कि अवेलेबल ऑनलाइन है सब है, तो आप इसको मेट्रोलॉजिकल सेंटर के साथ शेयर कर सकते हैं?
जरूर सर।
और दूसरा चीज है कि जो एग्रीकल्चर डिपार्टमेंट है या हाइड्रोलॉजिकल डिपार्टमेंट, क्या उनको ये जाता है डेटा?
हमारा एग्रोमेट सेक्शन को तो जाता है, जो घोष साहब यूज करते हैं इसको। And some of the products when
Not being sent present.
some of the state governments, if they ask, we give some input, but not on regular. But regular basis, it is updated to agromet sections of IMD.
And another forecast, how you do the forecast for future, week or month?
Yeah, because we have the forecasted rainfall data from GFS, weekly forecast data which we get, GFS. So we slide 1 week. So suppose here I can give you the example. So suppose this is to 1st May. So 1 week forecast data is used, and that it has been computed. We can use 2 week forecast data, and then we can slide 2 weeks, and we can use 3 weeks. So like that, we are sliding the forecast for the next 4 weeks.
Just I have to add one reply. See, basically for regarding drought declaration, it is the state government authority that declaring drought, and Ministry of Agriculture, Government of India, 2016 December, they have brought out proper drought manual where there is a 3-stage drought assessment. The first stage input is from IMD, that is the meteorological drought cause. In that, SPI is included, and the procedure is that at the end of the season or mid-season, each state government has to assess that based on all type of drought. Meteorological drought, that is the stage 1, then impact base where ground surface agriculture drought based on satellite, that is different organization, at least just like CWC and other organization they are doing. Each state they are collecting all the information, we are supplying to all MC, and MC is giving to state government. And final assessment they have done. We have seen that some of the state means at the end of they are asking for the budget funding, and from the central we have received that verification whether we have, just like for Rajasthan, whether you have issued, it has been done, SPI is followed or not satisfied. And if we recommend that it is okay, they will go ahead.
Okay.
So it is proper assessment.
Thank you. Let us thank Dr. Rajiv.
Thank you,
for a nice lecture. Now I invite Ms. Pallavi from CDAC. She will deliver a talk on the 4th one, coupled weather hydrological model for urban flood modeling and simulation. Ms. Pallavi, please.
Yeah, so good morning, all of you. Myself, Pallavi Gauri. I'm from CDAC. We are having a group, High Performance Computing, Scientific and Engineering Applications Group. So particularly our group is involved with meteorological forecast, doing the work modeling and simulations. Also, we are there with air quality, forecasting, simulations, pollution dispersion modeling. And associated with that, we are working with hydrology modeling simulations, particularly for urban flood forecasting systems. So now today I'm going to deliver this presentation for coupled weather hydrology model for urban flood forecasting. So this is under National Supercomputing Mission project. It launched by Government of India, Ministry of Information and Communication Technology. And this urban modeling project is mainly associated with urban issues. We are dealing with like disaster management associated with heavy rainfall, extreme rainfall events, and associated flood conditions in the urban selected urban cities. So why we have chosen this? Because like there are separate departments working in India few are working on hydrology, few are working on air quality and meteorology aspects, but all these things are interdependent on each other. Like when there is extreme rainfall, there is a flood situations might occur in urban, territories, and these data sets are like placed here and there. So we want to combine these things all together at one platform, and we are going to give this information to the policymakers, to the IMD, which is one of the prime stakeholder of this development, to the disaster management authorities, local municipal authorities and all. And ultimately this information will be given through various mediums to the citizens, which will be very much useful for them to understand the forecasting, flood forecasting, particularly in their region. And our main forecast is approach is like we are going to give the ward level forecasting system. So we are the main thing is like very high resolution models we have developed for meteorology as well as the hydrology things. Where meteorology we have tried to do the simulations for 1.5 kilometer to 500-meter resolution at urban level. And this is what the science what we have developed. It is through NSM. We are going to deliver to the public and to the policy makers under this mission, NSM mission project. So this is our system where we are having a lot of data from various data sources. Like we are having MODIS data, AWS data, hydrology data, and the data from like IMD, GFS data, ECMWF data, all these initial conditions, observations data, satellite data, which will be reposited in our data repository, and simultaneously it will go to our modeling platform like meteorology, hydrology, air quality, and CFD, and then we'll have different scenarios of like floods, extreme rainfall scenarios, and associated floods. Also, as well as the operational forecast, like day-to-day forecasting system for the urban regions. And all the inputs is going to processed in a very user-friendly way, where we have developed the indigenous visualization platform, and data reports and analytics will be given to the researchers, to the public, and to the city administrators and policymakers to take to support their decisions in tackling the urban disasters and their mitigations. And these are our end users. Currently, we are having main is the IMD. We are going to give this entire system. Hydrology, we are having researchers also. We are giving Pune Municipal Corporation, Bangalore Municipal Authorities, then Bhubaneswar, Ahmedabad Municipal Authorities. So these are our flood related authorities we are targeting to give our products. So now let's move to what is coupled hydromet modeling. So this is our approach. Like hydrology, we all know like there are a lot of open source models are available across the world, but we are more concentrated which model is suitable for Indian conditions and which has been weighted and calibrated. So first thing is like to develop those models, we have to acquire a lot of data. Then we have to do the catchment delineation. So if you take one city, Pune, so Pune city area is, let's say, like something around 535 kilometers square. But if we want to do the entire hydrological analysis, that area might be very less. We have to take the entire catchment associated, hydrological catchment associated with Pune, and we have to do the catchment delineation. Then we have to develop different hydrological models. We have to calibrate the models. Next stage is like how we have to couple these models with the meteorology models. So a lot of trial and error and a lot of experiments we have to do to exactly extract the meteorology data to the hydrology data. Then whatever the city is having in their premises, there are reservoirs, there are water bodies. So we have to take those things into count to do our hydrological modeling. Lot of validation, verification things involved, and then we are ready with the operational flood forecasting system, reservoir operations, and what level flooding. So this is the approach we have followed for our project for this coupled hydromet things. So let's concentrate what we have done for Pune. So we have taken the entire area of 2,250 square kilometer. You can see over here the entire boundary where we are having 7 different dams associated on the upstream side of the Pune city. So if you can see in the pink color, the Pune city, above that is the Pimpri Chinchwad Municipal Corporation, and this Mula, Mutha, Pauna, Panshet, Varasgaon, Mulshi and Kasarsai, Khadakwasla, all these dams we have modeled. Not only the dams delineated, we have done the entire hydrological modeling, like what is the, how many gates are there, what is the capacity of those dams, what are the FRL and maximum flood levels, and the maximum levels, like what is the rule cover applied to these dams. Simultaneously, we have incorporated the very high use land use land cover patterns to the entire catchment for the Pune. So it is 10-meter LULC we have used, and we have understood what kind of rainfall pattern which is applicable to the entire catchment. So the dam sites are already having a very higher level of rainfall as compared to the city areas. So we have to take these things into account while doing our simulations also. Then major important thing is we have to take the existing hotspots, like what are the flooded areas in the Pune city. So that will be helpful for us to calibrate our model, whether the results are coming accordingly or not, and we have to go further modifications in our model. And then the Nala basin maps, like whatever the natural streams are there, whatever the stormwater nalas are there in the city. So we have to take this information from the Pune Municipal Corporation, and we have incorporated in our hydrology models. So this is the input we have taken, and then we have to do a lot of understanding what is the causes of the flood in Pune. So because there are contributions from the reservoirs, when there is a release from the reservoir, the 3 major reservoirs like Khadakwasla, Mulshi and Pauna, from the outlet of these reservoirs, the city is getting flood from 3 different rivers, like you can see. There is a Mutha, Mula and Pauna rivers, which is actually affecting the city flood conditions. And what is the free catchment areas, which is downstream of the reservoirs. There are free catchment area which is contributing to the flood situations in Pune city. So this is how we got the results. You can see flooded areas, flooded hotspots, and the riverine flooding. So this is our model for coupling of with the meteorological data. So currently we have used 1.5 kilometer met WRF data and 500 meter WRF data as per the requirement and as per the rainfall conditions. And we have incorporated this data to our HECRAS, HEC-HMS and SWMM modeling system, where HECRAS is particularly the riverine flooding. HEC-HMS is the hydrology model which contributes to the free catchment area flooding, and SWMM model is particularly for the stormwater drainage systems available within the system. So this is a multi-model hydrology coupled with the meteorological data. So along with that, we have incorporated the reservoir operations also into our model. So we have taken the upstream side of the reservoirs, where the rainfall which is coming to the catchment area on the upstream side, we are calculating the runoff which is coming to the reservoirs, and we are getting the rise in the water level in the reservoirs, and simultaneously with the rule curves, we are also applying how much discharge needs to be taken out from the reservoirs, which is ultimately may cause the flood situations in the downstream area of the city. So this is the entire framework has been developed and currently under use for flood forecasting. Now we have done the entire automation of this system, like getting the data from WRF to running our different hydrology models, and then post processing and visualization. So there are a lot of scripts we need to develop in Pythons and JavaScripts and all, and this is like entire process has to be automated, where there should not be any manual interventions, and the daily operations or daily forecasting will be possible with ease for whatever the system we are going to develop, a decision support system. So this is the flow we have used, and the complexity associated with coupling and all. And not only this, once we are talking on the board level things, then we have to define our terrain. So So we have done a lot of efforts while defining the city levels, with making the city area in 3D digital platform, and then incorporating all the nalas and lakes within the city. So we have done a lot of bathymetry for the rivers and the lakes, and also extracting the building heights and rivers and stormwater dimensions. So you can see how the entire model has been developed. For this, we have used 1 meter, cross section, 1 meter contours for the Pune city, which we received from Pune Municipal Corporation. We have incorporated in our models. So the entire modeling framework and system is ready. Now we have done a lot of forecasting for and simulations for flood in Pune. So for this thing, first of all, we'll see like what is the reservoir operations we have done, where we have incorporated all the reservoir vessels as on date at the reservoir sites, and we have applied our modeling framework, where you can see over here like what is the inflow to the reservoir and what is the outflow. Means this is like observed and the calculated inflows to the reservoir by our modeling framework, and you can see like how the series of reservoir operations can be operated with the developed system and the forecasting. So we have taken all the water associated with like public water supply, industrial water supply, irrigation, and hydroelectric power supplies for those particular reservoirs. So for 2023, this is our results we got, and we are very happy, like, because for reservoir operations, we need to have 95% accuracy in our results. Yeah, and we got almost above 95% accuracy for our reservoir operations. You can see like the green line is the model simulated things, and the red one is the observed, where we are able to estimate exactly the inflows to the reservoir, and simultaneously if we are correct enough in calculating the inflows, then obviously we are very much assured of how much release of the reservoir should be taken place in or should be taken place by the authorities. And this is how we have validated, like we have forecasted certain release, and simultaneously that release has been happened in next or second or third day subsequently by the irrigation department people. So this is the ground truthing we have achieved. And this is like 2023, though it was very less rainfall in Pune city, but still we could able to capture few of the locations by our models, and you can see how the ground truthing has been achieved by our developed system, where you can, here we are giving the information like how much is the ward level flooding, where we are giving the flooding in terms of duration of the flood and the water level in that particular ward. So which area, which society, which road is going to be flooded, and for how much time it will get flooded. So we are happy, like we are able to capture the similar kind of event which happened, which forecasted and which really happened within the city. Same thing for different event, like September 23rd September. So we could able to capture those particular flooding areas also. This is like this was not done like forecasting, but we have done this thing as a model calibration things, where we have into 2022 also there was a big flood event in Pune, and we have captured those particular ground truthing, where we have simulated, and the kind of event has really been happened in Pune for that particular dates. Yeah, this has been used for model validation. For 22 and 23, we have done the quasi-operational runs. Now for 24 onwards, the system is ready for operational run forecast and all. And this is for 2019, where people from Pune, they must have experienced huge flood situations in Pune because of the release of the reservoir waters, and also there is a heavy downpour on the downstream of the within the city. So like even our model has predicted the same things, whatever the flood situations happened in 2019. So I just want to say, like, if we are very much good in modeling and getting the data from developing the hydrological model, it is very much possible to estimate the flood situations best, provided the rainfall forecast will be quite accurate in terms of quality and quantity.
Please conclude.
Yeah, and then for this, actually, I'm very grateful. We are having a very great meteorology and hydrology team. So we used to do site visit immediately after the flood event or during the flood events or rainfall events, and that will be useful for us to do the validation of our results. And also, we have done a lot of field visits also during the monsoon period, to understand the pattern of the disaster or the pattern of the flooding and the water level which we have projected, and whether it has really reached to that particular area, because our domain is like we are really working on the ward level flood situations and all. So we have visited all those flooded areas. And main thing is, like, we have developed this thing. So from 22 onwards, we have delivered this information to Pune Municipal Corporation, because they are our immediate users. And also we have given this information to Water Resource Department people, Government of Maharashtra, particularly the Khadakwasla Irrigation Department people, Mulshi and Pauna Irrigation Department authorities, so that they will have the understanding of what is the inflow coming to the reservoir and how much release they have to make. So we are happy because a lot of agencies have predicted 2024 will be a good rainfall event in India. So our model will be quite very much helpful for them to take certain decisions accordingly for the release, or to tackle certain mitigation measures in terms of tackling the flood situations. So, and also we have tried something associated with like 3D, imaging of the city, where one can have a very good idea of which area or which road or which society is going to get flooded because of the rainfall and the flood situations. So similarly, the thing has been developed for Bangalore, particularly by Indian Institute of Science, Professor Mujumdar, and his team has developed a similar platform for Bangalore. And this is how they also have done the validation of, the event 2022. It was a disastrous event for a flood situation in Bangalore. So the model has captured that particular areas also. And you can see the Veshri was one of the Rainbow Drive, where a lot of big shots they were leaving, and those areas got flooded. So with hydrological modeling, it is possible to estimate those kind of forecasting, flood forecasting.
Please finish.
And then we have done for some portion for because Water Resource Department people has requested us to do certain modeling for 2019 flood event for Krishna and Sangli River Basin. So we have developed that particular model for Krishna River Basin also, and you can see like there are possibilities, like we could able to see what is the rise in the water level at certain locations, so where it is a danger level at certain bridge locations, where alert can be given to the people, like just move to the safer areas, because this was again one of the very disastrous flood which started from 25th July till last till 17th August 2019. And the results were really promising, which can be used by the Water Resource Department people. Also, you can see how the model has been worked for that particular area, where we have given certain initial conditions, and after 5th of August till 13th of August, there was a disastrous flood situations, particularly at this area where the Mindering is there, and is this area where Kolhapur and Sangli region, cities are located. And then recently, 3-4 months back, we have started with Ahmedabad flood, modeling and simulations. And here also we are getting very promising results for this 20 July 2023 event, where we are able to find out the hotspots in the western side of the Ahmedabad, and our model is also giving the similar kind of pattern, and it is ground truthed also with the newspaper reports and all. So this information we are giving, our decision support system is under development. So it has to be very user friendly, understood by the common people. So we are giving the information in terms of water level and how much is the discharge at that particular area. And every after 15 minutes, the data will get updated, and there are information associated with the spread of the water and like level. One can see like what is the level if it a human is standing average height, and what is the impact on the like buses or trucks or cars. So these visuals will be really important for the common man to understand the water level and how they have to react in that particular area. So this is how like we have given some standard like alerts or warning systems like red, orange and yellow. So that will be helpful for the citizens to take some good measures in flood situations. And right now we have developed the modeling framework for Pune, Bangalore, Ahmedabad, then Cuttack and Bhubaneswar. But these are our pilot cities. But we are also ready with other important cities which are also facing, flood situations in their cities. So list is more actually. So these are the cities we already worked with high resolution land use, land cover, and certain hydrological features we have extracted to do the further hydrological modeling and simulations. And because this project is still under development, it is going to end in December 2024. So we are having a web-based integrated decision support system with a lot of information is available apart from the decision support system. So we are also having like under the system data modeling and simulation, post-processing and visualization platforms which will be useful for scientists and students, and also the DSS will be useful for the administrators and all. So it will be ready for any city to be a part of this framework. And since the framework is ready, we just need to do the hydrological modeling with certain inputs data required for that particular city to do the modeling and simulations, and they can have their own city get visualized for flood situations like that. So we are very much thankful to all these departments like IMD and NCMRWF, then NSM, committee, HPC resources particularly, because most of the simulations we are carrying out on, high performance computing sources. Pune water resource department people, municipal authorities, Pune, Bangalore, and also Odisha state, pollution departments and disaster management departments. So apart from that, CDAC is also involved with WRF training. So it is along with SAMA for South Asian countries. We also already delivered, online training on WRF, which will be useful for the students and even the researchers and the policymakers also to get involved into training, and we can help them out to do certain simulations and modeling in hydrology and meteorology. So thank you so much for your time and attention.
Quick comment, I think we can discuss in tea time, but any quick comment? Or
Okay, Dr. Pallavi, it's really good work. But I have got a couple of questions and just comment. One is that you are using, NSUP GFS, I think.
Yes.
So I think IITM, we have got IMD GFS is
IMD
always there.
GFS.
That is one thing. And then, this work will become matured. Only if you keep on, it will take some time before it matured.
Yeah,
I
yeah.
hope that you will continue to
Yes,
work
sir.
on that. And the third point is that how much frequently that land use, land cover, update in the model.
Yeah, so currently, since the project is still going on, so we have used the current land use, land cover maps. But once the city is going to have some changes into that, so we are going to incorporate those changes in our modeling system. Because Pune Municipal Corporation is doing certain changes at the Nala levels. Like we have developed the model, this model has been developed in 2019 also. But after 2019 September event, Ambilodha and all those things. Then they have constructed the Ambilodha and they have done some changes. So whatever like we have done that changes in our modeling system also. So we are continuously in contact with the building department and disaster management department of PMC, and whatever the information we are getting from them regarding the certain specific development or culverts and all those things. So we are incorporating into that.
My final, this is, because just I wanted at this point, that's why I put this question first. See, along with we give a forecast for flood, urban flooding, I think with this system, I don't know whether it is possible also that how you can make a changes in the land use or land cover so that floods don't occur in a particular area. See, before they construct all this,
Yes,
if you can give, these are the areas, and if you make changes here, it can reduce. I think that factor also may be very useful.
For that, sir, apart from the operational forecast, we are having a lot of scenario cases also, which is a part of this data hub. So scenario is like not only like what will happen next 72 hours and all. We are having scenarios of 25 years, 100 years, 50 years, and likewise. Also, we are having different other scenarios also. Let's say like cloudburst kind of situations. So that scenarios can be run, but for particular things, if we want to have some measures associated with tackle the flood situations, there are retention and detention ponds. So if it means we have carried out that activity also, like apart from the existing lakes, if we can create some open spaces and the water will directly go to the lakes, the constructed lakes, where the water will retain for a certain time and then it will go to the downstream areas or to the river, then the flood will be stopped at, means the flood situations can be tackled in a good way. Just like that, like reservoir operations now. Right now what we have felt in 2019, there was a release, sudden release from the reservoirs, where if the authorities will have a faith in the forecasted rainfall and the associated rise in the water level, they can release the certain amount of water steadily. So that scenarios we already have developed, we showed to them, but their problem is different. Like they can't rely directly on the kind of data we are providing. So we need to get a trust from them, like whatever the results are coming, that is useful for them. And this can be done because my personal opinion is like, let's not forecast the flood and just stop over there. We have to find out the remedies associated with how to tackle the flood situations. And definitely now in our NSM 2.0, we are working towards working on that. Like groundwater has not been considered over here. So we can have that groundwater recharge capacities modeling and all, where there will be contours or trenches or bunds, which is already under PMC, consideration. And the water, instead of directly flowing to the nalas and to the river, they will get, integrated within the soil. It will uplift the groundwater table and it will be useful for the cities to tackle the flood situations. Also, there are certain possible areas where we can have some spongy structures where the water will go. So this can be done in hydrological
There are
modeling.
two things. Of course, that may not be their domain. Even they suggest, policymaker has to take. They are covering, even you all nalas are being enclosed, rivers are being enclosed. Everybody knows that river behind here. So I think modelers, okay, that is a different domain.
Yeah.
I think let us thank Ms. Pallavi. Let us give it.
As suggested that to use that IMD GFS, actually we have already we are acquiring the IMD GFS, and then we are also integrating with the WRF, and we have found some improvement.
Yes.
Where when we are using that IMD GFS instead of NSAP GFS over the Indian region, and the model has been statistically rigorously verified.
Good.
Before for the operational use. Before operational use.
Yes.
Thank you.
So let us thank Ms. Pallavi again.
Thank you. Thank you.
So with this, the first session, I conclude. Let us thank all the four speakers, Mr. Saswat, Dr. Ashok Kumar, Rajiv Chattopadhyay, and Ms. Pallavi.
Thank you, sir, for chairing the session. So let's have a thanks class for our session chair also for nicely conducting these sessions. Now we'll have a short tea break. So we'll try to come back at 12 so that the next session will start. And before that, we'll have a small announcement. We are arranging a trip to the RCC Pune office for all our delegates from NMHS or our WMO lead centers and JMA colleagues. So we'll be providing more details during the lunch time. And this after this tea break, the next session will be chaired by Dr. Yoon Joo Lee, WMO Lead Center Korea, and rapporteur is Dr. Ananya Karmakar. So I would like to request all the speakers, please check all their presentation is uploaded on this PC during this tea break. Thank you. Please try to come back by 12 o'clock here.
ये लोड करना है, एनडीआरएफ का है और वो एग्रीकल्चर भूटान का। और इनका कोडाली सर का भी है।
खुदाई से का मेल आया है मेरे पास।
रखा है तुमने?
नहीं, मेरे पेन ड्राइव में है, मैं कर रहा हूँ। आपने सर जो मेल किया था वही है? हाँ, एनडीआरएफ का मिल गया। कब है इनका?
फर्स्ट वाला मेरा। सर कोडाली सर का फर्स्ट है।
उनका फर्स्ट है। एनडीआरएफ का पोस्ट लंच है क्या? हाँ, पोस्ट लंच है क्या?
हाँ, पोस्ट लंच। अभी कोडाली सर का है। श्रीवास्तव सर ने भी दिया।
ओके। सर्वर लेकिन कोई यूज नहीं कर रहा। लेजर कौन सी है क्या? ये फर्स्ट वाला है। अच्छा अच्छा।
वो स्लाइड का भी पुशिंग है शायद इसमें।
काम करता है वो।
चलो मार्किंग के लिए इधर से लोगों को इसका
एक बार खोल के देखो सर, खोल रहे
हाँ
कैसा खोला जाता
ये ना जी सर हाँ सर ये ओके किसका है? मेरा है।
इसका कहाँ से है ये अभी जो बोला कहाँ से उसका प्रेजेंटेशन?
पावर किससे है क्या?
कौन सा था ये?
अलग कर देता हूँ पोस्ट ठीक है।
प्रेजेंटेशन वो क्या लो क्लाइमेट चेंज
ये
हाँ हाँ उसको मूव होना है ना, ठीक है ना? हाँ एक बार खोल के शो करना।
यही है ना?
हाँ ठीक है,
लेजर यूज कर सकते हैं।
आपका फर्स्ट है ना आफ्टर टी?
नहीं सेकंड है।
आपका सेकंड है फर्स्ट
एज पर द एजेंडा।
हाँ सर का पहले
वो कैसे फॉरवर्ड?
ये
फॉरवर्ड बैकवर्ड
नहीं, ये मार्कर है पॉइंट।
ओके पॉइंटर।
हाँ पॉइंटर।
दिस इज फॉरवर्ड बैकवर्ड।
हाँ या वो मार्कर के लिए इसके हाँ हाँ नहीं नहीं शो पॉइंटर का यूज कीजिए वो इसमें ज्यादा आपने को हैंडी है हाँ ठीक है
Overall introduction to the government. We left आणि निवेन्यू myself and Dr. Moffat. interest level is easier. It is easier on the that you know we are going to start doing it for every year a little bit. Delay and Ruchikut and Murti and Jima Dima and we have to do everything. So different things, different significance. Jadi proses akad and tahu ini personalnya doesn't untuk study dan sudah tidak sudah kamu boleh mana and covered in a uncovered significant
Grade complete ini.
yeah 21st May CBS Oh, macam kurang na bani bedeva, dia dah kata yang ni so MBA ni na. Macam disaster management tinggi, punya uni saja tu saya betul. MBA meeting lalu, Prime Minister ni na, who to be officer dia, can I use that betul. So we can find that difference. Também sei. A minha filha que magana jazeena. A minha filha sabe que eu entendi.
One day.
One day na happy to have generation. This is doing. This is the shop. This is doing. Pouco de this coming.
Welcome back, everyone. Now we are going to start our next session, that is user-centric utilization of forecast information. So to start this session, I would like to invite Dr. Hyun Joo Lee, WMO Lead Center, Korea, to chair this session, and Dr. Ananya Karmakar, IMD, as a rapporteur. Over to you, Dr. Lee.
Thank you. Good afternoon. My name is Hyunju Lee from South Korea. I have worked in APEC Climate Center in Busan. Welcome. We will start this session 5. We have 4 presentations in this session. Yeah, first presenter is Mr. Vijay Kodali. He will talk about the climate service in energy sector. Yeah, please.
Good afternoon, all. I am Vijay Kodali from Western Region Load Dispatch Center located at Mumbai. Today I will present on the impact of weather on power system operation. Before going into the presentation, presently we are using the weather data from IITM Pune, and we are also getting the data from IMD. And for renewable energy, we are in discussion with NCMR WF for the renewable energy weather data. So here is the presentation. First, we will be covering these aspects like how we will do load generation balance in real time, and the impact of weather on the power system, and seasonal variation of demand and renewable energy generation, impact of cyclones, impact of solar eclipse, impact of rains, and use of weather variables in power system. Next, need for demand forecasting with effective from Indian Electricity Grid Code, that is 2023, with effective from 1st October 2023, and need for RE forecasting, weather parameter received at WRLDC, and weather data requirement at WRLDC. So all these things I will be covering in the presentation. Before going into this, just I will give brief about Grid India. What many of you might not be aware of what Grid India is, what it will be doing. Grid India is the independent system operator. We have National Load Dispatch Center at New Delhi, and we have 5 regions. We have regional load dispatch centers. Northern region we have at Delhi, and Western region we are having at Mumbai. For Southern region, we have our regional load dispatch center at Bangalore, Eastern region at Kolkata, and Northeast region we are having at Shillong. So we are in the job of ensuring reliable grid operation around the clock. So mainly in India, we are having central generating stations and some independent power producers, interstate generating stations. So from them, the power generated that should be dispatched to the states and some utilities. So we are doing the job of load dispatch from the central generating stations, and in this also based on the many requirements from the states. So a lot of products, how the power is getting dispatched to the states. So a lot of things all will be dealt by Grid India in the real time and in planning stages also. And we monitor all the grid parameters in real time. So all the electrical parameters like frequency, voltage, active power, reactive power, all we are continuously monitoring, and we will take appropriate actions to keep the grid in the safe manner. So here comes the how the system operators are placed. First will be coming policy making, that is the government, and we have regulators like Central Electricity Regulatory Commission, State Electricity Regulatory Commission. Then comes the system operators. We will be at National Load Dispatch Center, Regional Load Dispatch Center, and we are also having at state level, they are having state load dispatch centers. We play a vital link between the administrators, planners, regulators on one end, and physical system and market players at the other end. So looking at the load generation balance. So in India, the frequency is at 50 Hz. So to keep the frequency at 50 Hz, we have to continuously balance the load and the generation. So whenever there is the surplus power, then frequency will increase. And when there is a shortage, the frequency will get decrease. So our objective is to keep the frequency at 50 Hz or in the permissible band. So change in the load, it happens due to bad weather conditions, disturbances, and load change or boundary hours. Like in Indian scenario, at morning 6 o'clock there will be load changeover, and at around 8 o'clock, and evening 6 o'clock and 10 o'clock. In this boundary hours, there will be a lot of load changing will be there, and during that time there will be sudden change in the frequencies also, and housing and industrial load. So these all will affect the load. And coming to the generation part, in generation, due to the generator trippings, like due to faults or any planned outages, and the generation will varies, and due to evacuation lines from the generating stations, if they are tripping, so generation will be affected. And also wind and solar, the renewable energy, they are very variable. So depending on the weather conditions, they continuously keep on changing. So this is the very challenging task to monitor and to take appropriate actions. So next, coming to impact of weather on power system. So in summer period, during April to June, there will be heavy increase in the demand due to the rise in temperatures. And also due to for hydro generation, the reservoir level will be very less. And similarly for monsoon period, that is from July to September, there will be widespread rains, and there will be load crash and sudden hydro generation outage due to high silt content. This happens, and due to wet coal also, and the coal quality get deteriorated due to the rains. And during winter period, that is December to Feb, multiple element outage due to fog, smog, and low demand situation arises. And mainly coming to renewable generation, so variation in wind speed and wind direction, it keeps on changing, and variation in irradiance due to cloud cover, fog, astronomical events, like they are very intermittent. And coming to disruptive weather, there are cyclones, solar eclipse, gusty wind. So power outages will be there. It has happened in the previous period. So, and during solar eclipse also, that during that period, sudden variation in the solar generation. So all appropriate action to be taken at our end. Just because I am from Western region, I will just cover how the scenario of power system in Western region. In Western region, we are comprising of the states of Maharashtra, Gujarat, Madhya Pradesh, Chhattisgarh, Goa, and UT of DD and DNH. So this is how the pattern of demand, seasonal demand from April up to March for 2 consecutive years, 22-23 and 23-24. You can see how the demand keep on increasing. The red one is the 23-24. So the demand, there is sharp rise in some periods. So this is reflecting in this. And towards the right, we can see the wind generation and solar generation. So in Feb 24, wind generation will be very less, and the solar is there. So wind is shown the green color, that is very less, and spikes, that is the solar generation. And coming to the bottom, where it is July 23. So the green, this is the full wind generation. When there is rains, when the demand is less, we have high wind generation in the Western region. So these are the plots for state-wise we are captured to see where that demand is increasing state-wise. Maharashtra, we can see how the demand is getting increased, and for Gujarat, and state-wise we can see how the demand is getting increased. So next, coming to the cyclones, we have seen the Biparjoy in June. So we have captured up to 1 week the data, see how the demand is totally in continuous variation throughout the day. and how in the cyclone Taukte also, there is a lot of variation in the demand. Next, this also we captured the impact of solar eclipse on 21st June 2020. So there is a all India solar generation. There is a drop from starting from 10:08 hours up to 13:31. There is a sharp decrease in the solar generation. It reached up to from 11,160. It decrease in the solar generation is there at 11:51 hours. And also all India demand that also decreased during this period. So in impact of solar eclipse that we captured state-wise also, that forecasted and actual, we can see the figures. Maharashtra, we forecasted the reduction in solar 357 megawatt, and actual is 386. And Madhya Pradesh also similar. There is a lot of similarity during the forecast and the actual reduction in the solar generation. And accordingly, we have taken a lot of actions. So how to, when the solar energy generation is decreasing, we have increased the thermal generation and gas generation, hydro generation. Based on the requirement, we have taken appropriate steps to keep the load generation balance. So impact of rains also, it is captured in the western region. So drop of around 7,326 megawatt is observed. And solar generation during that period also it is decreased. These are some events that captured in July due to the impact of rains. How the solar generation and wind generation is varying. Next, coming to the use of weather variables in power system. We do demand forecasting and renewable energy forecasting. For demand forecasting, we use the parameters like temperature, rainfall, and humidity. And for wind, we are using wind speed, wind direction, and pressure. And solar, we are using the solar irradiance, humidity, and temperature. So why these weather parameters are required? Because in Indian Electricity Grid Code 2023, so it mandated that weather data is to be incorporated for forecasting demand on annual, monthly, weekly, and daily basis. We have to incorporate the weather data in the forecast itself. So weather data plays a prominent role in forecasting the demand. And for RE forecasting also, RLDC shall forecast generation from wind, solar, ESS, and renewable energy hybrid generating stations that are regional entities, and SLDC shall forecast generation from such sources that are intrastate entities for different time horizons as specified. So we have to, in planning stage itself, we have to incorporate the weather data. So the weather data plays a prominent role in this. So these are the weather parameters we are received at WRLDC: wind speed, cloud fraction, precipitation, solar irradiance, relative humidity, temperature, and rainfall. Actually, the operation-wise in Grid India, we are operating at 15-minute time resolution. So whatever we are planning for the generation and demand, so in each day we have splitting into 15-minute time resolution. Based on that only, all the forecasted parameters we have to incorporate. So, and in real time also, as per regulation, 16 revisions are allowed. So every 1.5 hour, there is a chance that we can revise the schedule. So if the weather parameters are available in the real time also, we can get a chance to revise after 1.5 hour. So 16 times we can revise the present day schedules. So this is our weather data requirement: day ahead, week ahead, month ahead, weather forecast data. intraday weather forecast data with resolution of 15 minutes and periodicity of 3 hours, bias correction of forecasted weather data through feedback of actual weather data of weather after completion of day with resolution of 15 minutes, so that we can check how much the deviation is there. More accurate weather data, forecast data for special events like cyclone, so that impact on power system assets like transmission system can be predicted. So this how in this way the weather plays a key role in our grid operations. Actually, generation and demand, they are purely they are dependent on the weather, like solar, wind generation, hydro generation, even thermal also. So the more the data of weather we can get and we can incorporate in our systems and models, the better we can forecast and we can execute in real time in an efficient way, and we can optimize also our resources, and we can save a lot of our elements from the disasters also. We can grid disturbances also. We can keep our systems safe and secure manner. That's all. Thank you.
Does anybody have a question or comment? Yeah.
Anju sir, do you have developed any model based on this weather condition and then power requirement? Any model, anything worked out? Forecast for power? Any equation you have developed?
Actually, we have incorporated renewable energy forecasting. We have given two forecasters like RE Connect, Enercast, LSOF, like forecasters. They will do. Actually, previously they used to get the data from ECMWF. So they are incorporating. We are not incorporating the ECMWF or data. They are incorporating in their models, and the output, how much that solar or wind generation may be, 15-minute block wise, they are sending to us. Model itself developed by forecasters only. And for demand forecast, we are doing like demand means if you are day ahead basis, we are doing. In day ahead, we are taking the previous day demand, and we are taking previous 2 weeks data. How that if today is Wednesday, okay. If you are forecasting for Thursday, we are taking Tuesday data and previous 2 weeks data. How that variation is there from Monday to Tuesday, how demand is varying state-wise. So all that and that variation, all that we are incorporating in our models. And with IITM data also, previously we, after COVID, we have MOU for 2 years. With that, we got the data from IITM on day-ahead basis. That data we are also using. With that models, we are doing with weather and without weather. Sometimes with weather is efficient, it is coming accurate. Sometimes without weather is because weather, it does not play a prominent role in all days. Sometimes weather will be same. So whenever weather changes are there, sometimes it is coming accurate. So we have to correlate where this because from IITM we are getting for 47 locations weather data for Western region. So but 47 locations, if you are seeing in which area that demand is rising or increasing, so with the 47 locations we have to correlate, then only we can improve the forecasting. And that too, demand forecasting, that error is for us is allowed only 3%. So if you are using weather, and in weather itself there is some error, and if you are incorporating that model directly, so sometimes it may error may increase or decrease. And for renewable energy, the error is allowed is only 7%. So within 7% band, if you are incorporating all these parameters and directly, and we have to see that whether it is fitting in that model or not. So actually, previously we used ECMWF data. They are giving spatial resolution for some 25 by 25 kilometers, and we want some more better. So we are checking how much accurate we are getting. We are improving the model. Then only we can implement, and we are continuously in touch with NCMRWF, and we are regularly holding meetings to incorporate these effects, because now it is 2024, because and with 2030s we have targets of 500 gigawatt renewable energy. So a lot of solar, wind is going to come, and with this there is a lot of intermittency in renewable generation. So now 15 minutes we are running with 500 megawatt gigawatt generation. So we need to move from 15 minutes to 5 minutes. So lot of things we need to implement in this.
Hello. So as you are indicating there is an error beyond 7% or within 7%. So did you give some insight that if that error is increasing more than 7%, how it is cost beneficial for the society? If the forecast is beyond 7%, suppose 10%, then how the cost benefits?
Actually, no, renewable energy, that forecast, it is very useful to states, because they have to plan. Renewable energy, if it is accurate, more accurate means they can reduce their resources, thermal or hydro. If that accuracy is more, so that then they have to make other alternative arrangements. So the more the accurate, the more they can use resources.
Okay, thank you.
So if the forecast is forecasting very accurate, no, then other resources they can back down and use very efficiently. And renewable energy, it is a very new one. In 2020 onwards, we started renewable energy management centers. So it is in the initial stages. So once this forecast accuracy is maintained, no, then lot of things can be done.
Nobody have, yeah.
Which one?
The product of forecast.
Yes. From 2020 onwards, renewable energy management centers are started in India, in all regions and national level. So already from 2020, we are using the forecast data.
Thank you.
Thank you, Mr. BJ Kobari. Thank you. Our next presenter is Dr. Aniket. He will give a presentation about the outcome response system for air pollution. Please come up to the podium.
Good afternoon, everybody. So I'm Dr. Aniket. I come from National Center for Disease Control. And as we all know, there's a national health program that is running from this National Center for Disease Control, from our Center of Environmental Health, Occupational Health and Climate Change. So we run the national program on climate change and human health. So I'm not a scientist, I'm a public health professional by qualification and by virtue. So we did not develop any model, rather we utilize the forecast data that is available to us from IMG EMRC. And we have tried to utilize this data, we have tried to translate this data into public health action. As a program manager, we have tried to utilize this data to find out some public health action that can be tracked down at state level, national level, sitting at the state and national level. So first of all, I would like to thank SASCOF and the organizers IMD to have me over here, our institute. I'm going to present on behalf of our institute, and it's actually a learning experience for me, trying to understand things in a better way, in a more scientific way. But I would like to share with all of you what our institutes in last couple of months have tried to decipher. So it's not only alert, but it's alert come response system, I would like to say. And since it's an August gathering, I need not to explain on the scientific terminologies, what air pollution is, what is indoor air pollution, what is outdoor air pollution. We all are aware of it. But I would like to highlight here that the impact of air pollution, it affects all the system of our body, including the respiratory system. So we actually run a surveillance system, a sentinel surveillance system regarding air pollution related illnesses. Across the country, we have around 389 odd hospitals, the sentinel sites, which report these air pollution related illnesses through the integrated health information platform. So we have a one surveillance system running in the health department, which is the IHIP, we call it, integrated health information platform. And out of this, in this platform, we do surveillance for air pollution related illness and health related illnesses. So there was a need to create and strengthen the AQI alert system. We were doing it, we were plotting this AQI data in a GIS map, and we were sharing it with across the hospitals, across the geography, across the state and the district. But what next? We did not have any idea what are the activities that were being performed based on these AQI alerts. As per the health advisory that we issue every year related to air pollution, what actions that they were supposed to do, were they taking it at all, or were it being neglected? So we thought of, kind of trying to measure the response that is being supposed to be done by these facilities. So the problem statement, if I may just briefly touch upon, we were thinking of developing a customized alert for the concerned geography, not one shoe fits all. So we are trying to, customize the AQI alert based on the AQI data, forecasted data that we receive. And we are trying to preempt the AQI situation. I mean, giving some room for the health functionaries to work upon. So this forecast data that were shared to us by IMD, basically, as we all know, it's the real-time data of yesterday, today, and next 2 days forecast. So we were trying to link the alert to the response that is happening on the ground, and that too giving us a, visualizing the responses from the state and the national level. And we're trying to identify the weaker geographies based on the response that we received. And even it can help us to correct the supply chain management, the real-time correction of the issues that prevails regarding the supply chain management that is required to manage these air pollution related illnesses. It also help us to create a intersectoral coordination, that is linking the mitigation measures with the adaptation measures. So if you may briefly touch upon the stakeholders, it's not only about health, but also the other department, the line ministries, line departments, that actually needs to act at the district and the local level. So this was the problem statement, which actually yielded to, kind of building upon the alert system. So as I have already mentioned, the AQI focus data, roughly around 48 cities are being shared to us. Right now it's being shared through an Excel file, but we are working upon to build an API system from the IMG to the IHIP portal that collects the data. And these alert system has a inbuilt, escalation matrix, if I may say, kind of a, first level officers being given the alert. If they do not respond, move on to the second level. If they do not respond within the stipulated time, then again we move on to the third level. So kind of a escalation matrix built upon in the system. We have NCDC team working on to monitor the alert response based on a dashboard that is being developed. The designated alert system will be finally rolled out to integrate in the IHIP portal. Right now, it's not being stored at the IHIP portal, but our vision is that when we expand it, we'll be plotting it into the IHIP portal. So as I have already mentioned, there will be 3 alert level. So first alert level would go to the sentinel hospital sites, wherein the primary data gets captured. If that health facility does not respond, then it would be escalated to the second level, that is the state nodal officers. And third level move on to the administrative officers, maybe the mission director's office or the state nodal officers in that case. I'll just explain the 2 arm that is there in this alert system. As I have already mentioned, the stakeholders for this alert and response, as we can see, this is the NCDC, the National Center for Disease Control, the IMD. We have some development partners helping us in doing this. These are the ADB, IQVIA, the Primus team. Most relevant one would be the state and the district team, the Sentinel sites that is guiding us with the data and the action plans. We are also looking into the municipality corporations, those dealing with the adaptation measures, if you may say. And we are also being supported by the WHO IT team, who is supposed to then integrate this system into the IHIP portal. And now if we come to the threshold of the alert, when is the alert going to be generated? As we all know, it's classified into 5 stages. So when we say the air quality has reached a very poor or severe or very severe for a continuous stretch of 3 days, then the alert is generated. And if it has reached severe stage for even 1 day, then also we are sending the alert. And if we have sent the alert for 1 day, maybe we are not going to send it repeatedly for the next 5 or 6 days. We give them some room of time to work upon, and if the situation does not improve or the action does not fulfill, then we are going to send the alert again to the same facility after 7 days. So this is the threshold of alert being generated. This is the swimline diagram, if you may say. It has got 2 arms. Basically, this alert ensures us to monitor, one, the health sector preparedness, the hospital preparedness at the sentinel sites. On the other hand, since it's a part of the program, National Health Program, the program functionaries that are there at the district level, at the state level, they are up to the task of building on the public health awareness that is there to build the community awareness, if I may say. So there are 2 arms and 3 levels to each of the arm. For sentinel hospital sites, the hospital preparedness arm, the first alert is being sent to the hospital. If they do not respond, it's sent to the chief medical officer that is there to the district. If he or she does not respond, then it goes to the state nodal officer at the state level. Similarly, when we say about the public health arm, first of all, it goes to the DNO, the district nodal officer. If he or she does not respond, it goes to the state. And if the state does not respond, it goes to the mission director's office. This is the mission director, National Health Mission. So this is in a summary how this alert and the escalation metrics works. And if I may just show you a glimpse wherein, it's an email alert that is being sent right now, but we are also working upon if it can be expanded to in a kind of a WhatsApp messaging to the fingertips of the program officers or the hospital sites functionaries. Kind of, if you may see a brief on what are the advisories that are there. So we also shared the link of the health advisory that is predominant for that year in terms of household, in terms of community, in terms of school children. Detailed advisory, the link is there. But in terms of hospital preparedness, if I may ask, I'll just read out for all of us, kind of a OPD services strengthening, kind of a emergency and referral services, kind of a preparation regarding the ambulance services, kind of a readiness with the medications that are required to manage this air pollution related illnesses, the diagnostic in the lab services, kind of a emergency services, if I may say, the oxygen supply, the nebulization that is required, the ventilations that are required, both invasive and non-invasive. And most importantly, the dedicated beds that are recommended, kind of stretchers and wheelchairs that should be made available in those sentinel hospital sites. So briefly, these are the hospital preparedness kind of summary that I have mentioned. we have also, provided with a part of public health awareness that I was mentioning. I'll come to that in the next 1 or 2 slides. And a link to the Google form here, if you can see, it's given here. I mean, every functionary who receives this alert has to fill this form, and that forms the data that aggregated data comes to us in the server. It's reflected in the dashboard, and we monitored that through the dashboard. We'll brief you on the indicators that are being monitored through the dashboard. So this I have already discussed. This is just a simple, yes no kind of response that we actually want them to document, not so much detail out. If something you want to mention, you can mention it in the remarks column, wherein if some remarks are observed at the national level or the state level, then the state and the national level can go back to that facility or the district. So these are the questions which we have already discussed. And regarding the awareness part, it's kind of interpersonal communication, mass communication, the IC materials, the posters, social media messaging. Every district or the facility have some social media handles, say X handle, or the YouTube channel. So whether the IC, the things that are recommended in the advisory to generate awareness for the public, whether that is being done, not only the public, general public, but also the patient that comes to the hospital. So kind of a community awareness, preparedness is also part of the form that is being shared through the email alerts. Now, we are doing piloting of this alert come response system in 2 districts of the country, preferably, as we all know, the Indo-Gangetic plain, wherein the air pollution menace prevails, and it becomes easier for us to monitor from the national level also. So we have selected Haryana and UP, from Haryana Gurgaon district and from UP Ghaziabad district, and we have tried to scientifically figure out based on the season that we have for air pollution related illnesses. It starts from September and it continues till the February. So it's a kind of a semi-quantitative analysis. If you can see the number of days wherein the AQI data were satisfactory, moderate, poor, very severe, and severe. So we have tried to figure out these 2 districts wherein 104 days, roughly around the days wherein it has crossed the threshold, and 89 days for Ghaziabad. So we're doing this pilot for last 1.5 months in these 2 districts. And if I may given me the permission to just to elucidate the benefits of this alert come response system, it's kind of a rapid dissemination of the information. It's not only the information, but data to action, what steps the district and the hospitals are taking in. Kind of an informed decision support system. It's evidence-based, as we have already seen. It also adjusts the preparedness that is required at the facility as well as the community. And about the public health awareness, the guideline that is there through the program, whether that's being followed at the field level or not. And this is also a screenshot of the alert, if you may say, that has been generated on 27th October regarding the forecast. Similarly, this is a Google form that I was mentioning with the auto escalation matrix that is there inbuilt into the system. So basically, when the matter escalates, it's not necessary or mandatory that the facility has to respond, but facility can respond, even the district and the state can also respond to that form. And if I may given, so this is the dashboard wherein we have highlighted few indicators that are being monitored from the state and the national level. So the number of alerts that were sent, out of which those responded within the 3 days, proportion of alerts that were escalated, and the response time of those alerts, and even how much of them has been escalated to the highest of level. So in a nutshell, I have just briefly highlighted our smaller interventions that we are planning. And since it is in the pilot stage, I would request the August gathering, if they have any feedback on that, just to improve upon that system, it's always welcome. So that's my time. That's all from my side. Thank you.
Thank you. We will open the floor. Does anybody have a question?
See, it's a really good work. So your center is a disease control center.
Right,
So do you do only AQI based or something else also you are planning?
Yeah.
Like
So, sir,
vector-borne diseases.
right, sir. Right, sir. So, sir, we had presented this to DG IMD, sir, also, and he has requested us to, widen it to even heat-related illnesses and also the vector-borne disease. I think we have met, sir, and we have discussed. And so we are planning, if you can meet and, discuss with the National Vector-Borne Disease Control Program that is also running through the NCDC. So we can do a joint collaboration. We have a wing in our program working for climate change and vector-borne disease. So we can very well include that also, sir.
Yeah, and the most important thing is that how many disease data you have with you.
So, sir, the IHIP portal that is there, Integrated Health Information Portal that is there, it's kind of a syndromic approach to the diseases as we know. Roughly around 31 disease data we have in IHIP portal. For our program, we are right now doing surveillance for only air pollution and heat-related illness. But we have sent IDSP program, Integrated Disease Surveillance Program, running through IHIP, which captures around 31 diseases.
So it's a district-wise data?
So, sir, it varies across. So for our disease, right now it's sentinel surveillance, so it's hospital-based data that we have. But for other disease, if you may say vector-borne disease, so it's till the level of laboratory wherein the diagnosis happens. So it's kind of a sub-district level, I would say, sub-block level even to some extent.
For 5-10 years data will be there?
Every disease is not so much matured, sir. Our program just started very recently. But other disease program, vector-borne, if you may say, it's I think it's previously it was Excel-based data. We have the data, but in platform we have data. Say last 5 years at least we have data.
So can this data be made available to the researchers?
Yeah. On request, it can be made available through DG sirs.
See, because what happened is that there are even CRS offices working on vector-borne disease. One of the most important is the disease data, which is not readily available. And I tell you, many times climate services, one of the main lacuna is the lack of sectorial data. Unless, we have a clearly mentioned under what weather condition this disease is increasing. So for that, a lot of research has to be done. So for that, unless we provide this data to researchers,
right,
that, we cannot decide on which window this disease. So I think that you should also put effort.
Sure, sir. So aggregate data, I don't think, sir, it would be a problem since it's anonymous data kind of aggregate. We can jolly well provide that.
So that will be great if you can provide the data. I think that will.
Yeah, we can coordinate and just get the data, sir.
Yeah, so this alert, there are, I guess there are two levels. One is administrative, like internal for the doctors and the public health workers. And another is the alert for the public. So how frequently you want to alert public and how frequently you want to alert the doctors?
So, sir, just to clarify, we haven't yet reached out directly to the community. We're not sending alert to the community. But as I have mentioned, there's a kind of a hospital preparedness. So hospital functionaries are given the alert. On the other hand, since we are running a national health program, so program functionaries are given an alert, and which indirectly kind of sensitize the community and generate awareness through the functions, through the guidelines that are there through the program, sir.
So do you have a community like this in health awareness, which it's like WhatsApp group or some group where we can subscribe to it? You have any?
Not yet, sir. We have not directly, till now we haven't reached out to the community directly, sir. Okay. So it's through the program that you can reach out. The concerned geography to the, it's running through across the country, all 800 district approx. So you can reach out to the district nodal officers that are there, not directly, sir.
Thank you for your presentation. I just have a quick question on how do you work with IMD? Because IMD, if you look at at the website, they have health bulletin issued by IMD itself. So how do you collaborate with IMD?
So, ma'am, just to brief you, there's a EMRC center at Delhi IMD office. So they on a regular basis share with us the forecasted AQI data, and then we try to generate the alert based on the threshold, sir. So it's a, daily basis contact and data sharing that happens.
So my question is, will you be collaborating with, other than getting just the forecast data, will you be collaborating with IMD for issuing the alert? Or
That's open side, ma'am. We are
it
open
has
to
not
it.
been clear
Yeah,
yet? Okay,
no.
thank you.
Sometimes in North India, there is a sudden development of dust storms. So in that case, how do you manage this situation? Though IMD, sometimes IMD may not alerted, but sudden development is there.
Dust storm.
Dust storms.
Okay, so we have not really thought into that, sir. I mean, we are concerned with the health outcomes of the community or the patients. So if at all medical management is required, and if at all it fits into any kind of organ system that is affected, whether due to the pollutants or whether due to the dust storm, it hardly matters to us. And so if the if it is related to that AQI level, so we can
that part of PM 2.5.
yeah. So that would indirectly raise that AQI value. So
yes.
in that case, the intervention would be the same. So that's what, if I, sir, may add on to it.
No, they are giving forecast. They are taking only forecast value only. A satellite figure, yes. That is something it is adverting from.
No, I think during the modeling exercise, these are all taken into account.
Okay. No, sometimes we are missing, no, sir. Okay.
Okay.
If nobody have further question or comment, we will move to next presentation.
Thank you so much.
Thank you. Lecture 2 presentation will be online. Next presenter is Dr. Santanubal. The topic is a long-range forecast and climate service for agricultural planning and management. Please give your presentation, Dr. Santanu.
Thank you. Thank you very much. Am I audible? Hello?
Yes.
Hello?
Yeah.
Am I audible?
Yes. Can you share
Yeah, just a
your
minute.
presentation?
So my screen is visible,
Not yet.
but it is showing that screen is shared. Am I audible?
Not yet. Please share. How?
The screen is.
Yeah. Yes.
Yes. Okay. So thank you very much, organizers, especially Dr. Srijit, Dr. Satyavan, for inviting me to this Climate Services User Forum. And my sincere apologies for not able to attend this particular meeting physically. And before I start, I just want to introduce myself. I am actually the project coordinator for the All India Coordinated Research Project on Agrometeorology, which is a project of Indian Council of Agriculture Research. And we have a very good collaboration with India Metallurgical Department, and we are doing a lot of research on agrometallurgical aspects, how climate is impacting the Indian agriculture. And besides that, if you look at the ICR, we have several projects like DICRA, National Innovations on Climate Resilient Agriculture, and other programs, which are really looking at the impact of climate and weather on agriculture. And so in that context, if you look at the long-range forecast, we can just feel that what is the importance of this particular forecast on the Indian agriculture. So in that aspect, I'll try to cover in broad, because time is short. So, and hope that you just get a brief idea about what this particular project and ICR is working, and in what way we are having our preparedness for the whatever forecast that we're getting from this particular program. We all say that, if we have a better forecast, then, our preparedness for the future will be good. And if you look at developing countries like India, and this climate variability at a seasonal scale has more importance, and country like India, which is mainly subtropical situation, if there is slight change in seasonal rainfall pattern, it can, have a significant impact on the agricultural output. And if you look at the Indian agricultural production system, if you compare, if you see for the last 20 years, starting from 2000, at that time, the production of food grain was more compared to the horticulture production system. But if you look at the current scenario after 20 years, we can see that the horticultural production has surpassed the food grain production. And if you look at the years where there is a drought-like situation, or there is a deficit of rainfall, the food grain production system has drastically impacted compared to the horticultural production system. So whole agriculture, if you look at, it is a complex system where the resilience of some systems are more, resilience of some systems are less. So when you look at any forecast, so we cannot take the whole agriculture as in toto. We have to look at the different systems and different setups. And looking at the recent past, this is just an example that how this shift in seasonal rainfall distribution is happening. If you forget about long-range forecast, this kinds of shift has compelled us to look at how this swing window can be shifted. And across the region, from the project we have just compiled that most of the regions, they have suggested that there should be a shift of swing window because there is already a shift in the rainfall pattern. And let's come to the long range forecast. If you look at the last 3 years, 22, 23 and this year. In 22, this was the SASCOF outlook and this was the realized rainfall. We can see that because this outlook is for 4 months, so we cannot say that, okay, this whatever realized rainfall was accuracy, but if you look at the month-wise and if you look at a final resolution, this kind of forecast actually doing a very well, job for the agriculture scientists to at least to get prepared for the, situation ahead. Not only the scientists, but also policymakers, government, that I will just include some of my next slides. If you look at the 23 scenario, you can see that the same thing happened that, the forecast was well taken and, a lot of similarity was there. And this year, the outlook is that normal rainfall over most of the South Asia. In India, most of the part will be normal, except some regions like Orissa, Northeast, and in the northernmost part of the India. And let's look at the ICR perspectives, how ICR look at all these things. If we look at the research part of the ICR, there are many organizations doing research in ICR, looking at how this particular weather and climate are impacting the, Indian agriculture. Out of that, this is the one project that I'm leading. We have 30 centers across the country where we are doing a lot of research on agroclimatic characterization, crop weather relationship studies, crop weather modeling, impact of this weather on pest and diseases. And of course, we are also supporting IMD in terms of agromet advisories, where my unit is developing a lot of algorithms, decision support systems. And the scientists of this particular project are also working as the nodal officer for the Gramin Krishi Mausam Subhar program. And in that way, we are doing a lot of research. And different locations, we are having different crops, long-term research, and looking at how this different weather variability and climate change is impacting different kinds of crops. And if you look at the monsoon, onset of monsoon, the onset of monsoon, it is only based on the rainfall. So this project is also trying to look at how this rainfall, in addition to the soil moisture dynamics, the amount of evapotranspiration, how all these things we can take and we can define a new term that we called as agroclimatic onset of crop growing season, so that if the farmers sow the crop in that particular, on the basis of this agroclimatic onset, the chance of survival of the seed will be maximum. And similarly, we have also tried to look at if the dry spell, because we know that this onset, then this break monsoon and the withdrawal, and in between a lot of dry spells are there. How these dry spells are impacting the different crops. So we have tried across the country how this. We actually tried to develop a new index. We named it as dry spell index, which is in terms of standardization SPI. And we have found that this dry spell index is performing better than SPI in identifying capturing the impact of these dry spells on the different, mostly rain-fed crops. And we have also tried to characterize the critical weather limits. For example, this year the forecast is that the rainfall is going to be less in a particular month or a particular period. So how that particular dry spell or break monsoon is impacting different crops. This is one example how this rice, we have tried to define critical weather limits for different variables like temperature and rainfall in different months. And also we know that though we say that there is an onset of monsoon, but the crop is governed by the soil moisture. So how this soil moisture is impacting the production. And this available soil moisture we have tried to link with, because now we know that the drought declaration is this percent available soil moisture is one of the factor or criteria for declaring the drought. So we have tried to redefine this percent of the soil moisture and impact on the crop yields. So these are some of the researches that we have done, and also we have developed a dynamic crop weather calendar taking into account the information that we have generated from different locations of our project with long-term experiments, and try to develop a decision support system to at least predict whether this is the best time to go for sowing, or is it the best time to go for irrigation, what should be the amount of irrigation. And this particular module or decision support system we developed, and we have tried to link it with the GKMS program where the agromet advisories were prepared. And we have also developed many softwares like DCWC, Dynamic Crop Weather Calendar, and also in collaboration with ICRISAT and IMD, we are also contributing developing this Meghdoot app. We have several apps through which we are disseminating the agromet advisories. And this is about what kind of research that ICR and this ECRIP is doing. And if you look at the monitoring aspect, these 30 centers which are also associated with GKMS, they are also monitoring the crop and weather conditions across the country, and using that information for preparing the agromet advisories and also for the dissemination. And also this particular project, ICR is a part of the Crop Weather Watch Group of Government of India, where every week there is a meeting and the scenario of the crop weather situation of the country is being discussed, and according to the policy decisions are being taken. And agromet advisory, if you look at in collaboration with India Meteorological Department, this particular project is preparing this NAS bulletin, this National Agromet Advisory Service Bulletin, using the extended rain forecast system. And this is being given to, disseminated to all the policymaking bodies. And another program that we are doing on a pilot basis, that we are disseminating or preparing this agromet advisories using the block level forecast. and disseminating to a pilot group of farmers and taking their feedback and evaluating the impact, and if there any improvement is needed, that kind of information we are trying to generate. This is about the government advisories, and then next is planning. And ICR, we all know that ICR has a number of research organizations doing research, and if you look at the technologies, lot of technologies are available. If there is a change in rainfall pattern, or suppose there is a delay in onset of monsoon, or there is a break monsoon, so number of different varieties, different technologies are available. And only thing is that India being a 50% of the area of the country is rain-fed. And this rain-fed agriculture, you know that what is the importance of monsoon on this rainfall agriculture, as sowing time where it is soaking rains. And if you look at irrigated conditions, this long range forecast of low rainfall helps farmers in avoiding high water demand crops. So these are all the basics that I don't want to just repeat. And if we go for this monsoon scenario, we know that there are three types of drought that may happen: early drought, mid drought, and late drought. And looking at that, different kinds of forecasts are available, and we are using medium range forecast and short range forecast for preparing the agreement advisories, which is disseminated by the IMD, and we are preparing the NAS bulletin based on the extended forecast. And the preparedness of the whole country is being done by the policymakers as well as the different universities and the state government departments using this long range forecast. And if you look at the planning aspect, we can see that IMD is giving a seasonal forecast, followed by SASCOF, then the CRIDA ICR conducting lot of interface meetings, especially at the state level with the state governments, and trying to include or implement the contingency plan. Contingency plan, CRIDA, the organization of ICR, has prepared the contingency plan of the 630 districts of the country, and that plan has been prepared keeping in mind the time of onset, delay in onset, lot of different scenarios. And that contingency plan we are trying to implement. Suppose, for example, this year there is a favorable monsoon setup. Last year it was a delay. So in that conditions, we try to make meetings with the state governments and try to implement the contingency plan in the state. And the second state forecast comes, then ECRIPAM, CRIDA also gives agreement advisory. So these are all the setup that the plan and setup that is there. How to use this long range forecast and other type of forecast in taking measures if there is some negative exposure is there. And CRIDA is also the lead center for the NICRA, National Innovation of Climate and Agriculture. We have a setup. We have a presence of around 151 KVKs where our centers are there. In ECRIP center, we have around 30 centers. So in the country, we have more than 180 locations. We are directly monitoring the crop weather situation, and if any aberrant situation is there, we can directly see that what kind of impact is there. And this is just a general decision tree suggested how this contingency measures, especially for the drought, is being taken. If there is a delay, what kind of actions that you can take. And regarding climate resilient technologies, I told that CRIDA is the leading center for the NICRA, and for different crops, different NRM, natural resource management practices are available. According to the report of the LRF, different kinds of crop production practices have been recommended. I'm not going to detail, but for every region of the country, we have the practices and the products available. So accordingly, based on the LRF and other advisories, accordingly, these different kinds of contingency measures can be taken. And these are some of the pictorial practices. If drought is there, what kind of intervention can be taken? This is another for contingency for rain-fed crops, especially for rain-fed crops. And these are some of the residential practices to cope with unseasonal rains. And different state governments, they are actively disseminating, sending the information to the state government officials, district level officials, even to the block level officials, and making a lot of meetings if some kind of contingency measure is required. And this is just a case study that if IMD issues something, suppose for example, on May 28th, IM issued that there is a normal rainfall for a particular region during the month of June. So what kind of recommendation like that, sowing is recommended, then, so this kind of, whole picture is there. If, for example, July 15th, almost no rainfall till August 4th. So what kind of sowing? So these kinds of information is our advisory has been sent, not only for the policymakers, but also for the state government department. So this is 2024. We have got the the LRF is already there. So now we have seen that there are certain areas. For example, the part of Orissa, then part of Northeast, the northernmost part of India, and some part of Chhattisgarh. This is where the probability for the rainfall is little bit below normal. So already the interface team is ready. So we'll be now discussing with all the state governments and look at the preparedness. What kind of suppose for example the onset is delayed or there is a break monsoon. So what kind of preparedness is there by the state governments, whether the particular type of short duration crops, the seed is available or not, other mechanisms. So that discussion will be there with the state governments of the particular region, and accordingly some kind of preparedness will be. So time was short, so I try to just give a in general of what kind of planning, preparedness, and impact is there. So I hope that within the time I have covered all this. So now I can expect a few questions from all. Thank you. Thank you very much.
Thank you. We will open the floor. Does anybody have a comment or question? If nobody have a question, I have a simple question. When you issue the advisory for agriculture field, you mentioned you use the information of the seasonal forecast. Just is the what kind of information do you use? Just only above normal rain, monsoon season, the rainfall? Just only one?
Actually, yeah. Basically, the advisories are being sent to different kind of users. The advisories for the policymakers will be different. The advisories for the farmers will be different. But when we try to use this LRF, the advisory that we give, it is for the policymakers, not for the farmers directly. And for the farmers, whatever agro advisories or agreement advice that we are preparing, it is basically based on the medium range weather forecast, or to some extent the seasonal forecast for that is for 15 days. But for the policymakers, we are using this LRF and just trying to sensitize that this kind of scenario will be there. So be prepared. The rainfall may be a deficit by this much %, or if the rainfall is, suppose for example, surplus, above normal is showing. So, and it is a hilly region. For example, last year, a lot of rainfall was there in the northernmost part, and lot of landslide, lot of flooding situation was there. So all kinds of scenarios we take into account and try to make an advisory and sensitize the policymakers, basically of the state governments.
Okay, thank you, Dr. Santanu, for your presentation. Thank you. Last presentation of this session, Dr. Manabendra will give a presentation. The title, oh, I'm sorry. I'm sorry. I'm sorry. Yeah. Dr.
So I think the talk was postponed after lunch. So
Yeah.
I'm here. I'll join after.
Yeah, I'm sorry, I forgot it. Yeah, next
No,
presenter.
no worries at all.
Yeah,
I'll see after lunch.
next presenter is Erkin Ijab. He will talk about the application of seasonal forecast anticipatory actions in agriculture. Yeah, please start your presentation, Dr. Erkin.
Hello, colleagues. Can you hear me?
Yeah, clear and loudly.
Can you see my screen?
Yeah, please start.
Yeah, colleagues, today I want to talk about it. First of all, thank you for your invitation. I am participating the fourth time of this SASCOF and user forum workshop. Here today I want to talk about seasonal forecast application for anticipatory action in our programming in agriculture sector across the region. And yeah, here this agroclimate and agromet service, depending on this temporal and spatial scale. And today I want to talk about anticipatory action. So application of seasonal forecast, seasonal outlooks, which we are preparing in our anticipatory action programming in agriculture sector across the region. So here is just a few words about what's the anticipatory actions. Anticipatory action, it's a proactive action which we are taking before this hazard happen to reduce this humanitarian crisis. It's a difference between traditional response after hazard happened and this is anticipatory action. And investing $1 from our experience across the region, like depending from country to country, investing $1 to anticipatory action will save 4.4 or up to $7 in comparison of traditional response. It's like our evidence collected from the last 2 years. And here, yeah, what's the main challenge in the application of anticipatory action? We have the main two challenges. First of all, this, of course, the observation gaps. For some countries, they have not so good observation network and low occurrence of seasonal forecast, especially rainfall. And here, what we have to propose it and to use to address this challenge. Yeah, in previous SASCOF-26 and 27, I was presented that depending on this different correlation coefficients, different indicator we are using to create the common drought index, and depending on the phenological stage of the crop. This example for Timor-Leste, depending on the climatology, dry season, rainy season, and depending on the main stable crop season. And also depending on the phenological state, different thresholds we are identifying, and depending on the threshold, we are activating our anticipatory action. Here, traditional, which we used last year, and across this country, the same methodology we are using for Pakistan, Laos, and other countries in Southeast Asian. So using this 4 monitoring indicator and two predictive indicator like rainfall forecast for 3 months, and so here we are usually use it in this approach your seasonal outlook to produce this kind of ability, and giving the weighting depending on this region and depending on the months. It's depend on the correlation coefficient. But after testing, we identified that old methodologies like red blended, highlighted with red, and with green, we have the solution. So old methodology is a weakness, the weighting system, inconsistent from grid to grid. Yeah. To address this challenge, we are proposing and now testing in Timor-Leste and PNG, avoid weighting system and calculate CDF for every grid by using AI. Second big weakness of old system is like multicollinearity of prediction elements. So we know that seasonal forecast and some IOD, Indian Ocean Dipole model oscillations, they are correlated each other. So to avoid this kind of multicollinearity effect, we are also utilizing machine learning approach to the bias correction of seasonal forecast. And gaps in observation network. So we are addressing this by using this data simulation techniques. Filter Kalman, sorry. Sorry. Yeah, for data simulation techniques by combined remote sensing and in-situ observation. So here's this in-situ observation. Here's the in-situ observation. So what kind of drought class we are using by WMO classification? It's standard precipitation index only for Timor-Leste, because temperature does not make sense. The variation of temperature amplitude is not so big. That's why we are using only in the tested standard precipitation, evapotranspiration index and other indexes, and we found the temperature variation is not so high. Only rainfall makes sense. And for monitoring is soil moisture anomaly precipitation index and vegetation health index. So this kind of classification proposed by WMO. And what kind of common drought index we are using? Here's the combination of SPI1, the last month's observation, soil moisture last month, vegetation health index last month, and upcoming 3 months rainfall forecast calculating SPI3. So it gives us monitoring of current situation like meteorological drought and forecasting agriculture drought by using this methodology. So this kind of verification method like hit kill score, we use it to verify our CDI, common drought index, and some quantitative element. And this one is for Timor-Leste example, where the data scale regions, they have only 3 meteo stations long. It's not long historical, it's like 20 years, even some station is less. So we are using this station to choose the best remote sensing derived index and reanalysis. So here I put only 2 examples because we are used also JAX remote sensing derived index, but I put the most accurate ones like CHIRPS and Error 5. And here we can find due to the resolution, like Error 5 length, they have like 11 kilometer resolution spatial. CHIRPS 2.0, they have 5 kilometer resolution. For the small region like Timor-Leste, small country, island countries, special resolution play curriculum role. And we can see like CHIRPS is better, the Taylor diagram, better performance for every month and for every region. And this CHIRPS data sets we're using every month and incorporating in-situ observation by using like, now we are using Nanjing for data assimilation, but filter Kalman we want to use in the future. And here this bias correction of seasonal forecast. What kind of approach we are using? Sorry. Can you hear me? So yeah, here input parameters. So for train this machine learning algorithm, we are using long historical data, and we use it EC WMF 3 months rainfall forecast, and also Indian Ocean Dipole monthly index, ENSO 3.4 monthly index, and also the in-situ observation. Yeah. So to catch the feature and all this geographic and climatic features of the region. And after training of this bias correction, we are doing every month for 3 months bias correction. And here this result of bias correction. So we can see like black one is like bias corrected. Adil Patisha. Black corrected. Sorry, my kid is here. Today is a whole day in kindergarten. So here is like black one is black highlighted is like bias corrected after bias correction. So we can see the significant increase of performance of this seasonal forecast of ECWMF. And here also one example for the last year, which we have piloted, 2023. So after bias correction, we can see the significant improvement of the forecast. And this is here is a CDI verification method. We are put here is last year, last 30 year and last 10 year. Here is the left side. We are using FAO stat national yield productivity data sets. Here we are using they have as Timor-Leste like new established counters. They have on the 10 years provincial level yield productivity data. So we can see that where is like here is the colors makes a CDI classification: mild, moderate, severe drought, and we can see from moderate drought to severe drought significant decrease of yield, and that's why we choose the moderate drought as a threshold we have to activate for this province in Timor-Leste. And so mild drought happened recently, but not really makes sense. Depending on this heat skill score, we calculated the skill of our CDI prediction score. So we can see like if it's heat skill score close to 1, it means a very perfect score. Minus mean, it means like inertial focus is better than using this methodology. But here we can see like close to 1, yeah. So mild drought, moderate drought, so it's quite not so bad skill of this CDI proposed methodology. And here we can put the drought year and also our CDI focus with 3 months lead time. And here observation of soil moisture in root zone from 1 meter, average from 10 centimeter to 1 meter. So very important for agriculture drought. Here we can see first month, second month, third month as CDI is carrying and 3 months lead time. And green one is like when our focus is hit. Yellow is like down estimated. White is overestimated. Overall, like 70%. We can say that accuracy of this methodology 70-75% depend on province to province. And yeah, here during us most monitoring indicator like soil moisture, rainfall index derived from remote sensing, we have 2 steps of triggering. First step of CDI, second step as a drought is slow onset. We have like 3 months before this by using CDI before the peak of the crisis will happen. So within the 3-5 days, we are conducting field verification. So second step of this. So here in Timor-Leste this year, we conducted our triggers reached the threshold, and we conducted field validation for some provinces and checking some different from the extensions from the farmers, looking what kind of crop condition, what kind of soil moisture, what kind of rainfall, what kind of water levels in main water reservoirs and rivers before activation to be sure. This kind of second step. And here, here we can see like as I said, we are using phased approach depending on the phenological state, depending on this like dry season crop, rainy season crop, and also main stable crop seasons, phenological. So what kind of anticipatory action should be taken depending on the phenological stage. So phase 0 for these municipalities we activated. In phase 1 and 2 for these municipalities we activated our anticipatory action in Timor-Leste. And here what kind of like action, the basic actions, like minimum actions which we activated, yeah, like phase 1, like early warning message, training on agriculture drought for these farmers. Phase 1, water access intervention, like disseminating water harvesting, doing other things, and drought because of this phase 1 is rainy season, yeah, before this. Drought resiliencies, cash for work, and other anticipatory action types for this kind of things. So conclusion, so CDI is give us a monitoring meteorological drought and forecasting agriculture drought. Sorry. Потише, я же разговариваю. Потише, сейчас не дам. So, and additionally, by using this bias correction of seasonal forecast, it's really helpful for this kind of islands. But we are tested in Indo-Pacific, and this year we want to modify our CDI in Pakistan, Bangladesh, Laos, and other countries in this region. So, and also this approach gives 3 months lead time, and as we are calculating it's a grid based, it's like from 5 kilometers to 10 kilometers, depending country to country, yeah? And depending on our computing performance, because bias correction is take a time and also data assimilation. So as it is grid based, let's say from 5 to 10 kilometers, we can calculate, we can overlay this CDI it carries 3 months lead time, overlay with population statistic like age, poverty, gender, and calculate potential impacted people and statistics. And also, depending on this, we can make our like anticipatory action, and of course, it can be used for response purpose as well. Thank you very much. That's all from my side.
Thank you. Does anybody have a question or a comment? I believe he perfectly covered the topic. If nobody have a question, I have a question. When you do bias correction of the seasonal forecast, you mentioned you use the some Nino index or IOD index and other variables. Do you remove the covariance between the variables? Can you hear me?
Yes,
Erkin?
yes,
Yeah.
yes, I can hear you. I mentioned it before. We are used it before like weighting systems, yeah, and we found that a lot of atmospheric process, ocean atmospheric process correlated each other, and the multi-collinearity effect. That's why to address this issue, we are using machine learning, XGBoost regression with hypertuning. It's taking account the multi-collinearity effect, this machine learning algorithm already. It's more powerful than linear regression and other things. That's why we are starting to using this AI. So in AI algorithm, this kind of multi-collinearity effect is already taken in account and already trained with short-term and long-term memory. So interaction between like Indian Ocean dipole, El Nino, Madden and Julian oscillation. But first of all, to make our computation lighter, we are like doing cross-correlation analysis for all atmospheric process. Yeah, we are using only significant correlated atmospheric process to make our computation easier. Yeah, so that's why for Timor-Leste, mainly this Indian Ocean dipole and El Nino makes sense in terms of rainfall. Yeah, pattern. That's why we use it only two in Timor-Leste, but depending from the country to country, it may be changed. Thank you.
Yeah, please bring the mic to.
Hello. Yeah, thank you for a nice presentation. Actually, I came a little late, but still I'll ask one small question. This application of seasonal forecast in agriculture, the granularity of the forecast, the uncertainties which are intrinsic, is there any model for financial implications or impact that we did something and it could benefit it to a certain extent? Are there any models you are visualizing, or is there anything like that? Thank you.
Yes, previously, no, not previously, we are still using your consensus outlook for this region, yeah? But this year, not this year, last year, we have started to use this application of AI for bias correction in Timor-Leste and PNG. But as you said, we are training this model, for example, we are first of all choosing the best model, yeah, for this region. For Timor-Leste, the ECWMF model shows the best performance. After that, we are using this hindcast and real forecast from 1993 to up to now to train the algorithm. And this AI algorithm is taken in account of evolution of the model and evolution of this errors of the model, yeah, truncation errors. So, and also it has like long-term, short-term memory. So depending on this, we are adding here like for Timor-Leste case, only significant correlation we had for Indian Ocean dipole and El Nino index, yeah. And also we are taking like ground in situ observation historical, yeah, to take in account how this model is like modeling, simulating this especially rainfall pattern, and then after training we are doing this kind of like bias correction. So, but every month the training is continuing by adding the last month's observation. So it's like it has like long-term, short-term memory. Yeah, this kind of things, and it really shows like how can I say bias correction of this, especially for the small countries like Timor-Leste, where the spatial resolution plays critical role. Yeah. And as we know from this graph cast from Google and other AI-based 10-day forecast, like not long-term, like short-term to from now they have probably 10-day forecast, yeah, and they show the accuracy is become much more better for than ECWM 10-day forecast, yeah, because they are trained all of them. But this AI model is based on ECWMF, yeah, and from the last 20 years, you can see also 10-day forecast from ECWMF reached this kind of what we are calling deterministic forecast. Hydrodynamic forecast reaches the highest. If you want to increase it, we have to have analytical solution of Navier-Stokes equation, yeah, which right now we don't have, and the 9 big mass problem, big mass task, which want to solve the 1,000 problem of the year, yeah, and that's why AI is now the last 2 years is rapidly coming to this focus, and we can see first result. But for seasonal forecast, the NASA and IRI also starting to the piloting project, and also ECWMF, they are starting this piloting project, but for 10 days to 45 days focus, but we need for drought like at least 3 months. And it's also now we are trying to like use this AI powerful tools in application of AI, yeah, in terms of anticipatory direction. Now we are using for a purpose of seasonal focus bias correction, but for example, in Mongolia, we have very good statistical historical data set. We will use it to identify the threshold when we should activate, yeah, depending on this impact, historical impact. But for some countries, we don't have this kind of statistical data to train this model. That's why we are like using only for seasonal focus bias correction. Thank you.
Yeah, thank you.
Thank you.
Thank you very much.
Thank you very much. Thank you, Dr. Erkin. Yeah, that concludes our session for today. Thank you all of the presenters to sharing your research. Thank you.
Thank you, Dr. Lee, for nicely chairing this session. So let's also thank our chair of this session for nicely conducting this session. Yeah. Now we'll have a lunch break, but I have a couple of announcements for that. After this lunch break, there are although it is the last session, there is very 3 important talks remain that is covering our 3 different sectors. That is from hydrology, Dr. Manavendra Sarya from IIT Delhi. And our one more talk is related to disaster risk reduction. And one talk from our colleague from Bhutan. So after these 3 talks, we'll have a short but formal concluding ceremony followed by tea. Then we are taking our NMHS participants, RIMES participant, and our colleague from Japan and Korea. We are arranging a visit for them to visit our IMD Pune office. So let's break for the lunch, and we'll try to come back here at 2:20 p.m. Please join here back at 2:20 p.m. Thank you. Welcome back, everyone. So this is the continuation of this user-centric utilization of forecast information session. As we already mentioned, although it is a last session, but there are three important topics are there covered by experts. So to chair this session, I would like to invite Dr. Rajiv Chattopadhyay from IMD to as a chair of this session, and Ms. Aarti Bandgar, IMD, as a rapporteur of this session. Over to you, Dr. Rajiv.
Thank you, Dr. Satyavan. So the list, the last one is the instead of this Manavendra, right? First, I believe. First, I believe. Okay. So the first talk is a district level flood severity index for India by Dr. Manavendra Saharia from IIT Delhi. It would be 20 minutes. So, good afternoon, Dr. Manavendra. Can you hear us?
Yes, good afternoon.
Yeah, please start.
Try to share. Yeah. So is my screen visible at full screen mode?
Yeah.
Okay. So good afternoon, everyone, and thank you for giving me the opportunity to present some work that we have been doing. And I'll be presenting some very recent work that we are doing in collaboration with IMD Pune. But before that, I'll talk about, basically there are two things in this presentation. One is a transboundary water modeling system over South Asia that we have been developing for about 3-4 years now, and a district level flood severity index that came as out of many discussions that I had with Dr. O.P. Srijit and many other collaborators from IMD Pune, and we have been working on this for many years, but recently we have also released the DFSI. We have communicated it to a journal, so I'll be presenting that work. So I'm Manavendra Saharia. I'm in the Department of Civil Engineering and Yardi School of Artificial Intelligence at IIT Delhi. So, before even going into the presentation, because of the audience that is present there, all of you are aware that India is one of the worst affected regions when it comes to floods, droughts, landslides. And floods are, of course, there is a lot of work that needs to be done in terms of anticipatory action and the modeling improvements that we need to do to provide such actionable work, actionable tools. So there are many improvements that we need to make. One is that we need to improve our understanding of hydrologic processes. We need to improve the way we collect observations and maintain observations. We want to improve our physics-based understanding of land processes and AI/ML models. And of course, we need to do research with an operational focus. So in hydrology, the focus is, majority of the work happens on a more diagnostic basis. But in the weather world, a lot of the work happens on prognosis. So that's where we are transitioning, and we are trying to do a lot of R2O, research to operations work. And one of the earliest work that I did in collaboration with IMD is actually developing an India flood inventory. So this was published in 2021. I joined IIT Delhi in 2020. And this was on creating a national multi-source geospatial database to facilitate comprehensive flood research. And one of the first things I felt when I joined here is that we don't really have good observations. So we try to do a lot of modeling, but observations are not either collected properly, or even if they're collected, they are not in a format that is easily accessible to researchers, especially for computational researchers. So we developed this database and we created a lot of, we did a lot of manual GIS work to make it happen, but it's available in public so anyone can use it. So this is the Indian Land Data Assimilation System that was originally funded by ISRO, and now we have several projects from Ministry of Earth Sciences, which is leading to continuous development. But essentially, it is a transboundary water modeling system that is entirely open source, and it allows you to do multi-model hydrologic model forecasts. So you have multiple hydrologic models. Currently, we have NOAA-MP land surface model, community land surface model. Then we also have other models that I have not mentioned here, like EF5, which are good for flash floods. And they are connected in with hydrodynamic models, multiple hydrodynamic models like HIMAP and MISU-ROUT. These are all global hydrodynamic models that essentially try to estimate 1D and 2D flows, and you get variables like stream flow, flooded fraction, flood depth, inundation, etc. And there are a lot of, as you know, like combining hydrologic models and hydrodynamic models is actually an engineering work now. So it doesn't require, it requires a lot of putting things together. But to actually make the flows good and useful at local scale, so there are a lot of enhancements that we need to do. And this is where we are working with HPC, working with things like HPC-based auto-calibration, data assimilation, post-processor that is machine learning based, ensemble stream flows, and we have reservoir and urban modules as well. So the one good thing about this system that we have, it is recently published in Journal of Hydrology. The good thing is that it is fully parallelized at both the hydrologic model layer and the hydrodynamic model layer. So for example, for entire South Asia at 0.1 degree, it takes us roughly 1 hour to simulate like around 1 year of daily simulations, where the modeling time step is 15 minutes. That's a massive improvement because now we have the building blocks in place to develop a national water modeling system kind of system. Because I know that the audience primarily comes from the atmospheric world, where you see the country as a continuum with the global atmosphere. But in hydrology, primarily, the focus has always been on basin-based studies. So people who develop models for Ganga, people who develop models for, Godavari or any particular basin. But now we are trying to move from that world to a more process-based world, where we are, because obviously floods in an area is a factor of so many things that are happening beyond the basin as well. So we are trying to go more towards understanding processes rather than understanding basins. So one of the first challenges that we face is traditional hydrologic models, or you can call them rainfall runoff models, are very easy to calibrate because they are, they are very light. You can use things like shuffle complex evolution, and you can get a good enough parameter sets because you run the model 10,000 times to get an optimal parameter set. Now that's not really possible with land surface models, because land surface models like NOAA-MP are very heavy. It has dozens and dozens of variables, and it is difficult. So we developed a new calibration scheme called fully parallelized dynamically dimensioned search. Wide US national water model for calibrating hydrology models everywhere in the country. But we have developed a fully parallelized version, which means we are able to get good optimal, I won't say they are the best parameter set, but they are good enough parameter sets that you can get between 100 to 150 runs, you can get very good parameter sets. Now that is useful because when you run any kind of hydrologic model on a regional or national scale, you still want to generate stream flows that are locally relevant, because ultimately your flood model is entirely dependent on being able to replicate stream flow faithfully. So using this model, we have now produced a daily 75-year 0.1 degree water cycle reanalysis. So from 1948 to 2023, you can get all variables like soil moisture, evapotranspiration, runoff, stream flow, flooded fraction, and you can get it on a daily scale. We have just wrapped up this work, and we have communicated it. We are communicating it actually. We have already communicated it, and we have done a very extensive validation using IMD's soil moisture network for soil moisture, ET validation. We have done stream flow validation using all these 100 plus red points that you see. These are all Central Water Commission gauge station data that we have collected. So we have done a very comprehensive validation of all water cycle variables. And we are, like, as soon as the paper gets accepted, we hope that we will release this data set to public. So hopefully there will be more and more use cases from other people, especially if in other sectors that people would like to use these variables. There are a lot of data assimilation components within the Indian land data assimilation system. I will not highlight everything. I'll just highlight one soil moisture product that we have developed in the interest of time, where we are doing SMAP soil moisture DA over entire country. And we have multiple forcings, MERA 2, IMD, CHIRPS. So we look at multi-forcing, multi-model ensembles. And we are using an ensemble calming filter to basically disaggregate SMAP to daily levels, and then we assimilate the errors and try to propagate them. And eventually we get a soil moisture product that we have validated, and we found that it's able to do better. In fact, one of the good things we found out that it's able to capture the irrigation signal in the country, especially in the northwest, like in the Gangetic belts, as well as the southern belt. So you will see many studies that have been able to capture the Gangetic belts irrigation signal, but very few studies are able to capture the Tamil Nadu, like this southern coastal belt, that is, it's not able to capture. So, or very few studies have been done in that area. So we were able to capture that signal, and right now we are in the process of wrapping it up in the form of a paper. But the good thing is that these we assimilated from 2015 to 2023, and the results are encouraging at this point. Apart from SMAP, we also do GRACE data assimilation. I haven't included the results. And we are trying to do multivariate DA as more, especially with NISA mission coming up very soon. Hopefully we will be able to do synthetic aperture radar-based data assimilation, especially of flooded extents. So hopefully that will improve our inundation estimates as well. But that's a work for the future. Now, as I said, you have to do many adjustments to make these simulations good for local scale. So one of the things we have been thinking a lot is, how do we actually use AI models, like these new models that have come up, or new improvements that have come up into old models. And one thing we have adopted is a strategy of a hybrid approach. So we can go, right now there is a consensus developing in hydrology that if you want stream flow forecast, then you can probably go to the AI model directly. You don't even need to worry about running a full-scale land surface model. Now, I have some disagreements with that, but apart from the theoretical disagreements, one thing at an operational scale, we do understand that apart from stream flow, we require the other variables. For example, soil moisture is very important for health scenario. It is important for agriculture. So we are interested in the other variables that we don't actually get from a machine learning model. So how do we do this hybrid approach? So we have looked at mostly at the post-processor part. And there we have developed a 2-layer long short-term memory. It is trained on stream flow data around the country, roughly 220 catchments, 220 stations. And we are able to immediately improve our Nash Sutcliffe efficiency from 0.13 to 0.53, just being able to post-process our stream flows. And good thing is that in machine learning models, the training is like it takes a little bit of time, but once you have trained it, inference is actually very cheap. So we will be able to run this operationally. So operationally, we emphasize that we have the land surface model and hydrodynamic model working in tandem, and then we have the post-processor that is also working real time to be able to correct the flows at a local scale, so that the stream flow simulations actually make sense and there is less bias in those flows. Now I'll come to the last part of the presentation, and this is very recent work we have done actually over the past 1 or 2 months. And we developed this original database called India Flood Inventory, and that stopped in 2016, and this was 2 years back. But recently we have been thinking that we want to develop a district flood severity index. And the reason is that the last time Central Water Commission developed a severity map for India was around 2013. So it's a little bit older map now, and of course flood situation is changing rapidly in the country, so we need to update them. Then NRSC also did a very similar study about 3 years back. They released it 2-3 years back. There are of course many good things in the study, is that it's a satellite-based study. It uses around 20 years of data, but there are also some missing points. For example, because it is relying on satellites only, it is not able to capture like flash floods or small floods that happen on a shorter period of time. So there are obviously, in any kind of method, there is always things that are advantages and disadvantages. So we try to develop this from a different angle of keeping those two things that have already happened from Central Water Commission and NRSC in mind. And for this, we just last month, actually, we released the India flood inventory with impacts. Now, what we have done is, because we have the 75-year reanalysis, we can find out what is the, historically, how much area of a district has been flooded. So you can see from, these are just some big picture information from the database. The number of flooding events you can see around the country on the map. And I have listed the top 3 districts according to this data set. So originally this data came from the disastrous weather events data set that IMD releases every year. But we did a lot of cleaning actually, because the information is, because as you know, many districts, sometimes they are like, they would have a different name every year, or like slightly different spelling. And you know, there are so many issues that come up in collecting any kind of data. So we did a manual, like we went through all the 7,000 events manually and corrected everything to come up with a good database. And we found that around one district, Thiruvananthapuram, gets around 4 events a year on an average. There are 5 districts in India that get more than 3 events per year, 28 districts with more than 2 events, and 101 districts that gets to experience at least 1 flood event every year. So, so we have collected this information. Now, how do we actually get from that, which is the number of flooding events, to a district flood severity index? So this is where we brought in our modeling expertise, in that we have a 75-year reanalysis. And this is like we used for 40 years, we used the calibrated reanalysis and found out what is the percentage of a district that is historically flooded. So using this number, you can see the color scale goes from around 0 to 14.5%. And at the highest level, it's roughly 15%. So you can imagine that the redmost districts in Bihar, in Assam, in West Bengal, and all this, in Orissa and all these areas, they get roughly, 10 to 15% of its district is historically flooded. So that means we have used the 40-year reanalysis to calculate an average. Obviously, every year and every month, that number is different. We have the number, but we wanted a single number that represents a climatological average. And then we developed this district flood severity index using an equation that is in the next slide. So we actually experimented with many permutation combinations of this equation, and based on our domain understanding, we try to, manipulate the numbers in a way that makes sense in reality. So this is the flooding events, which is the number of flooding events in a district. You have the mean flood duration, which is the flood duration of all flooding events in a district historically. Then you have the number of fatalities that have been in a district that has been recorded. Then in the number of human beings that are injured. Flooded area, which is the percentage of area of a district that is historically flooded. And the population data, we try to use census data, but the census data is actually quite old. And Facebook has a very good proxy data for population. We use that one to calculate what is the district population. But we have kept the equation quite simple, because we hope that this will be used, every month or every year, to be able to update what IMD Pune is already doing. So we try to not complicate it with too many variables, but simple, but still effective enough to capture the flood severity index within the country. And for this, I really want to thank Dr. O.P. Srijit for sharing many of the fundamental data sets and of course his insights as well in the paper. I would like to end mentioning that I have not mentioned much of the forecasting work. We do mostly forecasting work actually in our lab. We are currently executing 2 Ministry of Earth Sciences projects. One is the Brahma Satar, where we are developing an impact-based flood forecasting system for the Brahmaputra River. And we are kind of leveraging the tools that I've already showed here. But there we are more interested in LiDAR and like satellite-based flood mapping and doing this in a real time. Our focus is that we should be able to do national medium-range flood forecast within 10 minutes, in less than 10 minutes. That is our goal to do an R2O research work. And this is, even though the project is related to Brahmaputra, our interest is of course national. And we hope that we can run this within less than 10 minutes, the entire, like getting the meteorological forecast to be able to generate, finding out which villages would be most impacted. It's a research problem that we are trying to develop, address. And the second project is an experimental system for forecasting street-scale urban flood inundation by coupling physical and deep learning models. Again, we take a hybrid approach here, where we have the physical models, but can we downscale? Can we, make the forecast for urban floods? Urban floods is much more challenging than riverine floods. So we hope that using deep learning, we can bring in some new ideas to be able to do this at a very fine scale. And my focus on that project is that we want to do it at street scale. People are not really interested in knowing what is happening like in a river point somewhere outside the city, but they're very interested in knowing what will happen in front of their neighborhood. So that is something we are trying to focus on. And this is just a single final slide on very, very, very preliminary work. We recently received an archive of IMD forecast for about 4 years. So we are trying to do this in hindcast mode, and we are trying to develop this 0 to 3 day hourly streamflow forecast. We are currently prototyping over Narmada because we have a lot of data there, but the project is actually on Brahmaputra. So once we set up the system, we will simply ship to Brahmaputra. And you can see that the day one forecast obviously works quite well, and that is something we expect. But the day 2 and day 3 forecasts are not good at all when it comes to streamflow and inundation, flood inundation. That is because these are uncorrected, like these are not bias corrected forecasts that we have received. So we are currently trying to develop some bias correction algorithms. And then of course we have to do some bias correction after the streamflow is generated as well. So these are all, as I said, this is a very recent project, only 4 or 5 months have passed. But we are hoping that we will do some initial testing of the system this monsoon, so that by next monsoon we have a very robust system that hopefully we can deliver to one of the MOES institutes for running it operationally. So I would like to end here and thank you everyone for listening to the talk. I'm very happy to collaborate. We call ourselves the HydroSense Lab at IIT Delhi. We have around 11 PhD students, and I'm always interested in hearing from people and collaborating in any kind of disaster risk reduction issue. So thank you very much.
Maybe time for a few quick questions. Yes, sir. Thank you. Thank you, Manbendra, for a very nice presentation. And your visit to Pune is pending. You have promised long back.
Right.
I have 1 or 2 points. The floods in the northern part of the country and southern part of the country are 2 different books, probably. I mean, the reasons and the causes are different, because in the northern part, whatever comes from the higher regions, that is one of the reason for, that could be one of the reason for floods. 2 points. One is, since you mentioned about the 75 years of data that you have analyzed, so is there any, apart from the intense rainfall, which we put it with the climate change and global warming, is there any decadal window of flood affected districts or portions of the regions of the country in the sliding decadal window, so that this becomes one guidance that how badly we have performed in last 6-7 decades as far as the city planning or the urban planning or the district level planning, infrastructure development is concerned? Because not all the floods are due to the precipitation. Some of the floods are, maybe many of the floods are, could be narrowing down of the river and the infrastructure, unplanned infrastructure development that might have gone over a period of time. So in that formula, whether that variable I could not see, but I know how it, I do not know how this can be put into that formula. So this is only one my concern, so that if you can respond to it very quickly. Yeah, over to you, Manbendra.
Sure. Thank you, sir. So I'm hoping, actually, I came to know about this conference only 2 days back, because this would have been a perfect opportunity to visit everyone that I know, but I haven't seen in person, actually, met anyone. So, but I will be there soon. So about your question, so there are 2 questions here. One is that, can we look at the evolution of floods in the 75-year analysis? And that is, of course, we can do. And we are seeing that, for example, we looked at how much of a basin is flooded. And we have found out that even with the infrastructure that we have put in now, like in terms of embankment, especially in Assam and Bihar, a lot of embankment work has happened over the past 20 years and 20, 30 years or more. And you can see that even the generation of floods has actually, especially inland, that has changed, because every time there is an embankment, it stops the floods happening in that location, but it kind of pushes the problem downstream, because obviously you cannot build an embankment in the entire river stretch. So it kind of postpones the problem in a downstream. And you can see that happening in the model as well, how the evolution has progressed. So in Assam, I don't really have the plots here. For example, in Brahmaputra Basin, you can see that there is an uptick in the flooded portion. And we did some simple man-candle analysis tests, and we found out that there is at least a test significant increase of flooded area, which means the proportion of area of the basin that is flooded has increased over time. So we are still, as I said, it's a very new data set that we have produced on only 2-3 months old. So we are going to look at it in the future and in a more comprehensive way. But the second part of our question is, can we update this formula? Now that is something that we can do immediately, because you can see here that for example, the flooded area, 1+ flooded area that you see, this flooded area, we have put in the climatological number only for this paper's perspective. But this flooded area can be developed for each event, each season, anytime in the past, because we have the 75-year reanalysis. So once we have a flooded event, for example, say 24th August to 27th August, so we don't need to use the flooded area, the historical flooded area. We can find out what is the flooded area on those particular 3 areas, take an average, and then just regenerate. So in that case, this DFSI will transform from a climatological DFSI to basically an event DFSI. We did not go there at this moment because we kind of wanted to wrap up this first version of the work, and we released the data set as well last week. And but then it's a very nice suggestion, because converting it into an event is not very tough with the model results. So because the only number that is changing here is the flooded area. So we can do that.
Thank you. Any other question? So if there's no other question, I'll have a quick question. So what machine learning model you have used that was you have shown on the diagram, and how skillful it is? Just can you give an idea of the skill here?
So there are, so in this case, because it is a time series data, we relied on long short-term memory model, which is a deep learning model which is suitable for time series data. Now, the LSTM model is not trained on a particular basin. Like there are two, let me put it this way. So there are 2 layers to the model. One layer of the model is trained on the entire streamflow data set of the country, or whatever we have been able to gather from Central Water Commission. There is always some issue in getting data from CWC. So hopefully now we'll get more data now going forward. But around 220 stations we have daily data about maybe 20-30 years. So there we go and train our model, because we have the reanalysis and we have the observations. We train the LSTM model both, trying to form a relationship between them, and we use lag values of streamflow and all this, these are automatically taken care of them by the model. And then we have a meta learning layer where essentially we use local observations. So the reason we use the local observations separately is that suppose tomorrow Central Water Commission puts in a new station somewhere, right? We do not want to go and retrain the entire network. What we want to do is we have developed a national model, and whenever there is a new station in a particular area, we use the meta learning layer essentially to update the weights, which makes, because we are trying to develop these things hopefully with an operational focus, is that more stations come up, the entire model doesn't need to be updated, just the meta learning layer can be updated for that particular station. So once we do that, we take the simulations for 75 years, we bias correct them, and then you can see I put in some very basic statistics. So the median national subclave efficiency for ILDAS without any post-processing is around 0.13. And I want to mention here is that this is a very unfair number, because you can understand that there are basins that are very tough to model, like in arid regions, there are stations right next to a reservoir. So it is a very tough number to do well. But even with that, the processor, once you do the machine learning based post-processor, you can get the median national NSC up to 0.53. Now this number is actually, because it is a national number, you can see very high variance. In certain basins, they will be very high, and in certain basins, they will be quite low as well. But just for our internal target, we use the median because we want to develop this nationally. So yeah, so these are some basic numbers. But then again, this is these are initial results. I expect to improve them in the coming months.
Yeah, this is a monthly lead time. What is the lead time for this number?
No, these are all daily. So we only
Daily.
do bias correction at a.
Okay.
These are all daily.
Okay. Thanks. Okay. So thank you very much for your time. And so we go to the next presentation.
Thank you so much.
Yeah. Thanks. Our next presentation is utilizing seasonal forecast for agriculture contingency planning in Bhutan and next steps. Mr. Jambe Cheda. I hope your title I pronounced correctly.
Good afternoon, everyone. I'm Jambe Cheda from Bhutan, working under Department of Agriculture in Bhutan. So basically, I will be talking about the utilization of the seasonal focus in agriculture contingency planning. So this will be a very short presentation. In Bhutan, basically, the Department of Agriculture uses the seasonal forecasting to create awareness before the onset of monsoon. And also we use this seasonal forecast to allocate the resources to better prepare for the extreme events, as well as we use this seasonal forecast to develop crop insurance scheme and program to compensate the farmers. The Department of Agriculture received this JJS outlook from National Center for Organic and National Center for Hydrology and Meteorology in our country during the National Climate Outlook Forum. So after receiving the JJS outlook from the NCHM, the Department of Agriculture, we customize it and we disseminate it to different stakeholders, farmers, and by uploading it in our website, as well as we translate it in our national language, Dzongkha, to make them better understand and to have a better reach. So, and basically the National Center for Hydrology and Meteorology, they have they announce this outlook usually in the television, social media. So, and most of the farmers in our country are illiterate, so they might not be accessible to this information. So the Department of Agriculture, so we have a large network in the country. So we have 20 districts in our country. So within the district, we have many blocks. So there we have extension officers, district agriculture officers. So we disseminate this weather forecast via WhatsApp group, Telegram group, through website, and then the district agriculture officer as well as the extension officer in turn disseminate the information to the farmers and the end users. And in 2023, what we have done, what the Department of Agriculture has done is that based on the seasonal forecast given by the NCHM, we have, so it states that, for instance, the JJS outlook states that the precipitation for the year 2023 will be below normal. So in order to be better prepared for the upcoming weather events, extreme weather events, so the department has developed the water storage plan, as well as the mobilization of water pumps if there dry spell. So we have developed the plan, as well as we have also developed the proposal for fund allocation to compensate the affected farmers. So this is mainly to be prepared ourselves for the extreme weather events. There are challenges as well while we are conducting these activities. So some of the challenges are that the seasonal forecast provided to us currently is of limited scale over Bhutan, and the Department of Agriculture has just started using the seasonal forecast, and it is, I must say that it is at infant stage right now, and professionals in the Department of Agriculture is solely the agronomy professionals. So we don't have meteorologists and agrometeorologists in the department. Therefore, we have a limited skill to use the forecast and all. And moreover, there is no region-wise forecast in our country. So the department has felt that there's need to empower the planning and decision making in terms of agrometeorology and agro-advisories, and as well as there is need to enhance the dissemination and utilization of this weather and climate forecast in the country. So with the fund support from World Bank and in collaboration with RIMES, we have developed ADSS, Agromet Decision Support System. It's a web-based portal. So the development has been completed, and the implementation of this activity will kickstart by June 2024. So there we will generate the agro-advisory using the different range of forecasts, like we use 5 days forecast, 10-day forecast, monthly forecast, and seasonal forecast as well. And moreover, we, in collaboration with RIMES, we have also developed one mobile app to have better reach to the farmers. And in the mobile app, we have one feature that is the voice advisory. So those farmers who can't read and write both the language, English and Dzongkha, our national language, they can hear the voice advisory as well. So in order to kickstart this ADSA system in the country, the department has planned to first practice this system in the piloted Dzongkha or selected Dzongkha as a primary step, and then we are like working together with NCHM as well, and we are planning to further strengthen the engagement with meteorology center in the country as well. And like I said, we don't have much, like we are limited of the capacity or the technical capacity in the country in relation to this agrometeorology and the meteorology system. So the department is planning to enhance the capacity of the professionals as well. And then we are also planning to establish the former climate field school as well to create awareness as well as a model school or the knowledge center for the farmers. And the usage of the seasonal forecast in the country is like I said, it's at infant stage right now. So we hope that the Bhutan, the agriculture department, will be using the seasonal forecast as well as other weather forecast, as it's very much important and necessary for the agriculture sector to integrate this weather forecasting as well. So that's all from my side, and thank you.
Thank you. Any question?
So thank you for a very nice presentation. You can invite all of us to your country. Your country is beautiful.
I would love to invite.
I said it's a suggestion. Regarding you mentioned in your presentation, the skill about the agromet forecast is not very matured in your country. So what if your government wants, or if your authority wants, maybe India Meteorological Department can do some hand holding. Maybe
there could be some communication from your office, and we can plan certain joint activity, especially in the agriculture forecast, and also some guidelines in the observational network also. Of course, I know RIMES and World Bank are working at your place, but maybe as a neighboring country, we can have little more collaborations out of SASCOF also. This is my just suggestion. Thank you.
Thank you.
Yeah, thank you for that excellent present. I have a slightly different question. Bhutan, as I understand, also has well-established traditional communication of information, particularly in farming and agriculture. Because these traditional approaches sometimes have a better trust compared to the modern approaches. So is there any attempt to actually to integrate the modern scientific information into traditional practices?
Basically, while forecasting the weather, so NCHM in collaboration with the Buddhist astrology, so they usually collaborate themselves and they forecast the weather in the national level. So in case of agriculture, most farmers usually follow the traditional method, and it's very hard to convince them right now. So we are trying to incorporate them as well. Thank you.
Thank you. If there is no other question, thank you very much again. So we come to the next talk, final talk of this session. Last but not the least, utilization of early warning system in disaster response from Mr. Ravi Prakash, NDRF.
Good afternoon, everyone. I am thankful to SASCOF and IMD to providing me this opportunity to address this August gathering. Till now, every speaker has spoken about how different models have been planned and developed by their organization and department. But NDRF is the end user, which uses those early warning system for effective disaster management. I am Ravi Prakash, second in command. I am posted at NDRF Pune. I will be speaking about the importance of forecasting agency in dealing with disaster. NDRF stands for National Disaster Response Force, and it works under the operational command of MHA. National Disaster Management Authority provides the policy guidelines. It is an amalgamation of 5 different CAPF, which is mandated to respond on any type of disaster, whether it is a man-made disaster or a natural disaster. The role of forecasting agency is of paramount importance as far as this natural disaster is concerned. During my presentation, I will be speaking in brief about the role and responsibilities of NDRF and collaborative efforts for disaster preparedness and future direction for enhanced safety. Following the super cyclone of 1999 in Odisha and 2001 Bhuj earthquake, Government of India realizes that there should be a legal framework to deal with disaster or disaster situation in India. Thus, this NDM Act 2005 was enacted, and Section 44(1) of this Act provide a provision that there should be a specialist force in the country which should deal with the disaster type of situation. It started with 8 battalion in the beginning. Today, NDRF has 16 battalion and 28 regional response center, which is spread across the country. The regional response center are the small unit of the battalion, which is deployed in different part of the state to enable faster response. Like in the state of Maharashtra, we have our battalion headquarters at Pune, but Maharashtra is a big state, so we cannot reach as early as possible in other part of Maharashtra. Like Nagpur is quite far away from this place, and Mumbai is overcrowded. So if there is something, some situation is there, it will take a lot of time. So keeping these things of point in mind, regional response center has been established at different part of India. We are having 2 regional response center in Maharashtra, one at Nagpur and one at Pune. NDRF personnel are trained and equipped to deal with different type of disaster, collapse of structure, search and rescue, medical first responder, CVR and emergency response, flood water rescue, mountain search and rescue, canine and technical search, animal disaster response. Here I would like to invite the role of forecasting agency in the flood or flash flood type situation and cyclone type of situation. NDRF has got 3 type of rule. During peacetime, we train. We carry out mock exercises with different stakeholders, which includes industry, railway. We conduct a school safety program to educate the children. We conduct familiarization exercise to collect the data so that in case of any incident, we are aware that what type of situation we may face in that scenario. Besides, we are providing, we are giving training to the police, civil defense and home guards on regular basis. During disaster, we respond. And this, the role of forecasting agency is important during impending disaster. Like during monsoon, we get the information. We receive a regular alert over our information center that this much of rainfall or cyclone is expected. So the troops are deployed during these impending disaster to minimize the loss of life and property. We provide a specialized response during any kind of problem, whether it is natural or man-made. And we provide assistance to the state government in conducting rescue and relief operation and distributing the relief material, establishing a medical relief center and mitigating the impact of natural calamity. The role of forecasting agency is of very important, as we get timely, accurate information 72 hours before any kind of problem. Like we are receiving IMD forecast on daily basis. In case of cyclone, we are receiving 72 hours prior to the event. So we are mentally prepared and we are in a position to deploy our troops and know the problematic area which may face during the disaster, and we mobilize the troops accordingly. If the situation is green, more mobilization of troops or positioning of senior officers is required. We do it on the basis of alert received from the forecasting agency. During monsoon season, it is observed by all the rescuer of the battalion that what type of situation is there in our area of responsibility. Like for red, we are on alert mode, that it's a warning level, and we are mentally ready to take action. For orange, we are alert mode. On when it is yellow, we are on watchful mode, and when there is a green color coding, then there is no warning. Why this color coding is important for our point of view? That if we are not aware about these color coding and we are not aware about the forecast, then we won't be able to take preemptive decision. And so it helps us in taking the decision, because in the past what we have experienced, that if action is not taken on time, we may not reach at the location where evacuation and search operation is required. The trees may be uprooted, the road may be washed away, and we may not reach to the location. So these alerts are very important for us. The impact of these forecasts can be seen From I have taken super cyclone of 99 as a baseline, where we have lost 10,000 lives. And in the recent cyclone, the sweeper joy, the casualty was restricted to 16. It was all possible because of the timely and accurate forecast by the agency. For collaboration, we keep on exchanging program at various level. We have information. We are getting regular information from the agencies, their expert views, and we are working in close coordination with the IMD. And whenever there is a need, we conduct joint training program also. As many speakers have spoke about the impact of climate change, so maybe in future we can think of integrating the impact of climate change in forecast, so that in advance we can prepare. Apart from this, community-based disaster risk reduction initiative is required, and by keeping abreast with the latest development and emerging trends, we can educate our men, our citizens, so that loss is minimized and there is no loss to life and property, and we can safeguard their livelihood also. So by collaborating with the forecasting agency, it will foster a holistic approach in effective disaster management. Thank you, Jayan.
Any question?
Thank you for this excellent presentation. It gives us a good idea of the NDRF. I have two related questions. One is, do you maintain a catalog of weather and climate extremes, which you can use in terms of their general characteristics to prepare and plan your activities? The other is, even if you are dealing with a non-climatic disaster, you will need weather and climate information for your operations to make sure that you are able to provide the best response. So how do you actually access that type of information in your operations?
Correct, sir. We maintain a database in our operational branch that what in last, like our battalion was raised in 2005. So we have the data since 2005. Okay, what are the problematic area in the state of Maharashtra, that which is our primary area of responsibility. That with the experience we have learned that the majority of this flood-like situation has taken place in the 6th district of coastal region, Konkan region. So our prime emphasis is on that, and with the experience we know that sometimes we may face problem in the Chandrapur area because of the mingling of 3 water river system. So we keep the data, and before every monsoon season we go through it and we assimilate it with the present day forecast. And as far as your second question is concerned, that is a very valid question. During a chemical disaster kind of thing, we have to cater for the environment. So what type of situation is there, whether it is a daytime or evening time, because the chemical disaster may impact the rescue. Means our rescue operation has to go in semblance with the climatic condition of that area. So we access during those kind of situations.
Please go ahead. Yeah, I come from Bangladesh. Actually, BMD, when any warning issues, that time DDM, Disaster Management, Department of Disaster Management coordinate this, and all department go through the DDM, Disaster Management, and we have SOD. It is a standing order of disaster. So in India, who is coordinate all our department when any disaster come?
Okay, as I said, that MHA has the operational control of all the disaster-related activity. There is an agency called NDMA, which is headed by Prime Minister of India, which provides us the guidelines. And in India, we have a legal framework. It works at 3 levels. NDMA at center level, SDMA at the state level, and DDMA, which stands for District Disaster Management Authority, which is headed by district collector at the district collector level. Whenever there is an incident, this DDMA is considered as the incident commander. And anyone working on that incident site will come under the operational control of District Disaster Management Authority, and all the forces working at the site will come under the operational control of district administration, district collector. So this is the constitutional framework. It is 3-tier system.
So thank you. First of all, I will request all my participants here to give a round of applause to the wonderful work that you are doing for the country. You all are the real heroes, I can say. Whenever the disaster happens, we see at the site, you are the first person, to reach there and to rescue the life, which is very precious. So thank you very much for that wonderful work. I've got only 2 suggestions. One is monsoon is coming. Earlier, we have in Mumbai, we have one, your team is deployed in the stadium, I remember, at Andheri. So we used to conduct one annual workshop with them related to the, related to the monsoon forecast and related, understanding if there are any new things related to the alerts, early warning system, etc. And also then the NDRF team also used to demonstrate how they do the flood rescue or, the rope rescue, many things. So it used to be like, a sort of half day or 1-day workshop. Maybe we can think of this before monsoon with the IMD in Pune or something like that. You have a station at Lonavala, am I right?
Yes, sir. Our headquarters is at Sudumbre and it is nearby Dehu cantonment.
So we can think of this maybe.
Definitely, sir. As I said, during peacetime, it is our prime duty to impart training and educate the citizens and all the departments. It is done on the regular basis for civilians also. So there is no issue. We can conduct it. And at Mumbai also, our one company is deployed.
Yeah.
So at Mumbai also, it can be done. We do it on regular basis.
Okay. Let us work out the logistics. The second point, which you mentioned in your slide, very interesting, I found that, currently your team is, NDRF is responding for weather issues, sir. Probably climate related issues. Of course, for that, you don't require, to prepare it for, the way you prepare it here. But maybe the climate related issues, maybe NDRF can have some long-term or short-term planning, how they're going to manage those types of disasters in the coming time. So to understand that or to create this type of environment in NDRF, probably NDRF may also would like to understand what is the expected things happening in the climate projections as far as the the country is concerned or the state is concerned, and how to understand what are the climate forecasts which are there. Related to the heat wave, related to the extremes that are going to happen. You mentioned many of them. Maybe we can have this type of interaction with your unit, so that maybe in the long term, this inputs can go regularly as a part of developing a strategy related to the climate change. How NDRF is going to handle the climate change scenarios in the coming time. Now also you are doing it, but maybe, of course, you must be having SOP, so many things would be there. But if we can do something, please let us know. We'll be very happy and eager to participate in this component from climate side. This is what I was trying to communicate. Thank you.
Thank you very much, sir. You have rightly said that the challenges are evolving every day. And we are continuously on to the task of upgrading our knowledge and upgrading our skill and upgrading our inventory. And so we boast of having 320 plus state-of-art equipment in our unit. So since NDRF is a responding agency, we can keep ourselves abreast with the knowledge of climate change and what type of scenario we will face. We stimulate that kind of situation, and we train and we practice. The rest is not in our hand. So we concentrate on our work. Like in the morning session, I heard the presentation of CDEC from Ms. Pallavi that was of our use. So I collaborated with her and I said, I will definitely call you at my place to brief our ground commander. If I know something, it is of no use because I cannot disseminate everything to everyone. So my ground commander should know. So if something is of value, sir, we can always collaborate with IMD for our skill development and knowledge development. Thank you, sir.
Thank you very much. So I think this is the three talks in the session. So I hand over to Dr. Satyavan for further announcement.
Thank you, Dr. Rajiv, for nicely chairing this session. And I would like to request everyone, please thank the session chair as well and as the reporter, Dr. Rajiv. Now, this is the part of we are approaching this concluding session after 3 days very hectic discussions. As we know, actually because some of the discussion was going so well that due to time constraint, we have to stop actually. So also that is how it is differentiating compared to the last couple of SASCOF event that was conducted online, and now after a 4 or 5 SASCOF session, we have conducted this offline. We see the way we are interacting, the collaboration is happening, discussion is happening, the new knowledge we are gaining, that is really insightful. So now, as a part of this concluding session, we have a plan that we would like seek opinion from our NMHS participants as well as a couple of user sectors. So I would like to ask alphabetically that our NMHS participant to share their experience or whether they have any comments and suggestions regarding this SASCOF event as well as the Climate Services User Forum. I would like to request our colleagues from Afghanistan to share your experience or any comments and suggestions. Anyone is from Afghanistan online, please? Yeah, if not, next go to our colleagues from Bangladesh to hear from them. Nasir Ahmad sir, are you there? Miss Soma, are you there online, please? Okay, we can come back to them later, so we can hear from our colleague from Bangladesh, please.
Yeah, thank you so much for the opportunity to say something. Actually, very fantastic work, I think, that this workshop. Last year, the SASCOF result was below normal rainfall in Bangladesh, and basically our result also below normal. So it is a very good result last year. And I think that this year, so the above normal rainfall in Bangladesh, it is good for especially the agriculture sector, because we know that Bangladesh fully agricultural country. So if you have good rain, that good agriculture, and already our media people at night to call me, what is the result? And they are eagerly waiting the disseminate this result, what is the SASCOF result. So I think that this type of workshop, it is more beneficial because it long-term forecast is very difficult for like the Bangladesh country, because Bangladesh is short-term okay, but long-term a lot of challenges. But with this type of SASCOF program, it is very handful and nicely forecasting for the seasonal forecast, and it will very helpful for our. I think that this type of forecast we should proceed with the every season. I think that not only the monsoon, already the winter also, and it also means suppose the pre-monsoon, post-monsoon. So my suggestion that it can be extended for each seasons for this type of activity. And another thing that we have a lot of presentation here, and they are end user, especially the energy sector, agriculture sector, a lot of sector analysis, and also disaster related. This knowledge is also helpful for our decision making, especially the planner, also the high authority. When I inform this kind of issues. Thank you all from Bangladesh. Thank you.
Yeah, thank you very much for your comments.
Sir, I think AMD participant.
Is there
AFD.
anyone from Afghanistan available to share your comments or suggestion or any feedback? Otherwise, you can, Ranjanji, please just drop a message whenever they are available online. On mic is not working. Okay. Okay, you please try to connect again. Oh, yeah.
From this side.
Still, we can't hear you.
Hello.
Yes. Please go ahead. We can hear you.
Okay, sir. Sorry, a few minutes. We have a technical problem. Can you please ask me again, and I will answer what you want.
Yeah, now as a part of this concluding session, we are asking each our NMHS participants to share their experience of this SASCOF event as well as this Climate Services User Forum. And even if you have any comments or suggestions or recommendation, that we'd like to hear from you.
Okay, we have a suggestion. I shared yesterday too about the models that Dr. Srijit sharing because we are using our seasonal forecast from the NASA models. Sometimes it's can't capture, it's not near to actual. Because of that, we want some of the models, and Dr. Pai said that we should email to Dr. Srijit, and after this workshop, I will send an email. And also, we want to know about the what method they are using to produce drought SPI index, because we are working on SPI index. And we are creating the graphs and also the map, and we want to produce our SPI index by AMD2 for Afghanistan.
Okay, thank you.
This is our suggestion for the SASCOF.
Yes, please.
No other comment from our side.
Yeah. Now Dr. Srijit is responding.
Okay.
Yes.
Thank you, Soma. We will consider your request. We will share the model output to you by email or in the next month onwards. For about that SPI, we will definitely help to calculate that SPI for your region, that our Climate Research and Service Office will, RCC, always help for that also. Thank you.
Thank you, Dr. Srijit. Yeah. Now, our colleagues from Bhutan to share their experience.
Thank you so much to all the people who are part in conducting this SASCOF. For me, it is my first time attending SASCOF in person. I was present in the COVID time when it happened virtually, and I am of thought that in person is much more better than virtually, because we get to interact with people and get our doubts cleared. I have heard that in our previous SASCOF, there used to be pre-COF where we used to come together and try to run the CPT together. Having that in coming years, I hope it wasn't possible this time, but I believe it will be happening in coming SASCOFs. So I'm looking forward to that because a lot of doubts on CPT can be cleared when we come together and do it with the experts present there. So that is my suggestion. Thank you.
Thank you very much. Yeah. Our colleagues from Maldives, if they are here. Okay. Our colleagues from Myanmar.
Yes. Thank you so much for this 3-day workshop. Actually, we learned so much knowledge. This is very supportive for us for the preparation of our seasonal outlook. I have also some requests. I would like to request, like in future circles, we would like to learn the Python CPT. Currently, like using the Python code and CPT is very popular. So our country also, we would like to use more effectively Python CPT in our seasonal focus. And another one request is to produce the Highway Index. Because our country also, currently we also face the so much warming trend, so much high temperature. Even this month we have the record depth 48.2 degrees Celsius in the central part of Myanmar. So in future it will be very we need that knowledge or like the technique also. So we also would like to produce the Highway Index also. So in future, I expect we can get these two training by the CBT and the producing the Highway Index. Thank you.
Thank you very much. Our colleagues from Nepal, please.
First, I would like to thank organizers and the supporting institutions for inviting us in this program. So as we have seen in last few days that how we started as an like whether the monsoon is going to be South Asian monsoon is going to be below normal or above normal to this stage where we have national level seasonal outlook. I think this is one of the success story of the program that WMO has launched, and all the supporting agencies the work of theirs is really appreciated to come to this stage within 14 years of time. From Nepal's point of view, it really has helped us to institutionalize the seasonal forecasting in our country. I think it has helped to develop the capacity building of NMHS in seasonal forecasting, bringing users to coordination and collaboration with the users community as well. And within these 4 days, what we have learned is what is happening, the new innovations in seasonal forecasting, weather modeling, climate modeling, and also more we have learned how the users are using it is very knowledgeable, and I think we can take it back to our country and do similar kind of things. And I have a suggestion for the SASCOF forum. What we expect from the SASCOF is continuation in capacity development for the NMHS, especially in outlook development, outlook of monsoon, monsoon and synoptic features, sub-seasonal outlook, and also the teleconnection part. We wanted to see progress on that aspect. Second, in the product development for the users, like there was a presentation on impact-based seasonal prediction for not only for a few sectors, but we want to expand that for various sectors as well. And third, I think we also need to have some kind of capacity building for awareness and capacity building of the users itself, how to use our products. With these three suggestions, I have a request from Nepal that if we can have a mechanism, some kind of mechanism developed under SASCOF, where the model data, the seasonal prediction data and outputs are shared, so that we can test and we can verify, see how the models are working. That is done in India and in other parts of the other institutions which are working in seasonal forecasting for South Asia. And finally, because I think we have a representation from WMO here, so it is a little different than the seasonal forecasting, but I would like to have similar type of forum. This is a suggestion. Similar type of forum will be helpful for the climate projection, capacity building in climate projection and climate change studies in South Asia. Thank you.
Thank you very much, madam, for your valuable comments. We are noting down all these comments from all the participants. So we'll see how these comments can be implemented in this future SASCOF event in collaboration with all our co-organizers and as well as the support from the WMO. Now I would like to ask our colleagues from Pakistan. I hope they are available online. Anyone from Pakistan, if you are available online, could you please share your feedback? So we can.
I would like to
Hello,
add.
sir. This is Suma from AMD. I have one more suggestion. Sorry for late. We want more information about NFCS, National Framework Climate Service, because UK Met Office was worked with us in 2021. But after that, the change of government, they are not working with us. And I also request from Jane, but we want from you also that WMO should do this work with us also, and we should go ahead to do the steps of National Framework Climate Service also.
Okay, yeah, thank you. Actually, as we recently, yesterday we heard from the UK Met Office, because WMO is already updating their NFCS implementation guidelines in collaboration with the UKMO, and it was a very fruitful group discussion as well. And we'll try with, in coordination with our UKMO colleague, Dr. Jain, we'll try to prepare what are the summary point that was discussed and how that can be helpful for other NMHS country to start the NFCS from basics to go forward. That whenever something is available, we will try to share with you. And we are very happy to see the comments from Jane as well. So whenever, Dr. Jain, are you trying to say something here?
Hello, everybody. Good afternoon. Although it's still morning here. Do you want me to give my closing notes now, or just respond to Soma?
Yeah, just to that, Soma, if you want. I will come back to you again for final remarks. Yeah.
Great. Thank you, Soma. And it's really great to hear that you're enthusiastic about developing the national framework for climate service in your country. Yes, we would very much like to connect with you because we need direct interaction to really understand what your needs are in terms of development of a national framework for climate services. I've put my email there in the chat, but please send me an email and we can organize a meeting to discuss the next steps.
Okay, thank you, Jen.
Thank you, Jen. Yeah. And I would like to ask our colleagues.
I was, like trying to say the last point that I'd like to thank the supporters of RHYMES and all the organizers for supporting us. Thank you.
Thank you. Now I would like to ask our colleagues from Sri Lanka to share their experience.
At first, I would like to thank IMD, RHYMES, UK Met Office, and the WMO for organizing this SASCOF-28 and inviting for us. Actually, SASCOF is very grateful, great helpful for us when preparing the next Southwest Monsoon outlook. Actually, this is providing us very valuable guideline when preparing our outlook. We could share our knowledge and we could gain more knowledge about the various section. Thank you.
Thank you very much. Yeah. Now I would like to hear from our colleagues from GPC and WMO Lead Center. They also have joined here. So we would like Maldives. Oh, they are not here. Actually. Yeah.
Thank you. Thank you for corresponding to the SASCOF meeting. I visited in first visit to India, and I saw the summarizing the consensus forecast in SASCOF in situ in this place. And my suggestion is as Nepal department suggested. Not only the objective forecast result, but the dynamical interpretation of the predicted atmospheric large-scale circulation. In particular, in this year, the La Nina-like SST anomaly pattern and a positive IOD-like pattern is predicted. So the impact, the response of the tropical convection and the associated large-scale atmospheric circulation is also modified in association with the positive IOD and La Nina. So dynamical interpretation for the response, atmospheric circulation response, is also needed to assess in this SASCOF meeting. So these interpretation give us further information or the knowledge or the and the evidence of the SASCOF forecasting. Thank you very much.
Thank you very much. Our colleagues from Korea. So.
Yeah, I'd like to express my appreciation to Dr. Rees and all organizers who have put this extraordinary conference together. I'd like to thank you for inviting me in the middle of progress in SASCOF and the hospitality that they have extended to me. Actually, I have concerning to how to deliver our climate information for helping society to become more resilient to coping with the increasing climate risk or climate change. I think we can find a good way to solve this concerning due to be concerning about this issue with many people.
Finally, I hope I can have an opportunity to be here again in the near future again. Thank you.
Thank you, Dr. Lee. Now, I would like to ask any of our user sector participants are available here. We want to hear from a couple of them. So if any of our user sector, they want to share their experience or how this SASCOF and climate solution. Please go ahead.
First of all, I want to thank IMD and IITM for inviting Grid India to this conference. Actually, in our day-to-day operations, we are getting a lot of benefit from the observations or alerts you are issuing to us. Yeah, from our top management level itself, whenever they get any IMD alerts, they simply alert everyone in our organization and to take preventive actions and inform all the stakeholders so that any event may come, we should be able to face it. So the data provided by IITM and IMD, it is very beneficial to us, and you gave us this year opportunity to meet all our users so that we can know about each other. And I thank you for inviting me to this. Thank you.
Thank you very much. Please go ahead.
Thank you very much. I would like to say congratulations to the organizer to come with the good conclusion for the South Asia this time. And I am the first time I'm just participating this event. I learned so many things from the IMD platform, how to utilize the product and how to make the utilization of product for the stakeholders. Now the thing is that people are asking so many things. After watching this group closely, so what is the new development is happening? That was known very well. So what are the limitations and how can we achieve in a short period of time? That was learned from this 2 days exercise. So I will give the big compliment to this group. They are coming with the new products and having the passionate to work at the different levels also. And they are assigning this work not only for India, they are including all the South Asian group and looking this forum very well and promising to come out with the new products that are really having the gap, so that they are bridging the gap, what actually required and how can they fulfill this gap. I will think in coming years or coming days, we will have a good system. Today, one of the presenter, he has come with the good dashboard. So that dashboard is very lively. So we can come with so many things. So these things required, people are demanding, planners, even the stakeholders. So this integration is happening very good and very fast, tremendously. So I'm very much happy and I'm expressing my sincere thanks from my side and from my organization that the organizer has given chance to interact with you. This very well, what we say, acquainted and very good. I don't have the proper word right now, but I'm thankful for all the SASCOF forum. Thank you very much.
Thank you very much. Actually, as this SASCOF event is being organized after many years, we try to invite all the user sector that is the under high priority for the NFCS, that under the GFCS, that is water, agriculture, disaster risk reduction, energy, health, all these sectors we invited, and we are very happy that we got very good response from all the user sectors here. Next, I would like any other user sector representative. Yeah, if not, we want to this program, if it is says it is a successful, that is one of the reason is there is a strong support from as always from our RIMES, UK Met Office and WMO. So at first, I would like to hear from our colleagues, Dr. Anshul Agrawal from RIMES.
Participants for coming here and participating very actively in the SASCOF session.
that basically makes the success of the session. And then our colleagues from IMD Pune office who are very actively engaged, and despite of so much of difficulties, there are a lot of changes happened after COVID, and in terms of organization, in terms of procedures, rules, regulations. So even till today, our colleagues sitting outside, they are facing various challenges with respect to the organizations, logistics, so many things. But despite we were able to make up this event, get 6 countries participating physically here, all the users, various user sectors. So that was a good success for this SASCOF, and for that I would like to congratulate Dr. Satyaban, Dr. Srijit, and the entire team under leadership of Osalikar sir, so to make this event successful. So the role from RIMES is always RIMES is playing an important role for SASCOF organization since long time, and I am also involved here for last many years. So for that support will always continue, sir, and under the leadership of IMD Pune, RCC Pune. So we would like to support SASCOF events in future, and we would like to also see more user-centric products coming up. Likewise, what we have seen today, last 2 days, so many new products developments are happening through different institutes. Very actively, they are using these seasonal outlooks and generating generating the products, decision support systems to take these products forward for the various kind of applications in different sectors. So with involvement or active involvement of the users, not only from India, from all other countries. So we would like to see the application of these products, more and more application, and for the benefits of the communities for whom all these products have been generated, and our scientists are working tirelessly for that particular purpose. So with that, I would like to thank again everyone who are present here, who are joining us online. We had many participants sitting in the room, since we are only for this purpose, but participants, they are joining online, so they have a lot of distraction. Despite that, some of the participants are regularly joining for last 3 days. We are getting very active involvement of them, also their comments and response to our queries and all. So that is also heartening. So with that, I would like to thank all of you, and for our colleagues who has come from different countries. So wish you a safe journey while going back home. Thank you.
Thank you, Dr. Ansel. Now I would like to request Dr. Jane Strassen from UK Met Office to share your final remarks, please.
Good afternoon, participants and guests of SASCOF-28 and the Climate Services User Forum. So on behalf of the UK Met Office, I want to thank you all for letting us be part of your important proceedings. I'm sure you know I would have much preferred to have been with you all in person as planned, to meet you all in 3D, and to have conversations with you all about climate services and climate science during the lunches and tea breaks. We all know that that's often when everything takes place, when we get some really good discussions going. But I've joined all of the discussions online. I've learned and heard so much about the breadth and depth of activities and capabilities being undertaken across South Asia, not just in the seasonal science space, but across all climate services sectors. We've heard about the vulnerabilities, information use and adaptations in the water management sector, in the agricultural sector, in the energy sector, in disaster risk reduction, to name but a few. And as I said yesterday, it's when we bring together the expertise and experience from across the climate services value chain, from the producers of the weather and climate information to the translators of that information through to those who are actually using that information, where we can really start to co-develop and co-deliver climate service solutions that are fit for purpose. And we've seen examples of this happening again and again in the presentations of the past few days. I want to thank you in particular for helping make the interactive session on national frameworks for climate services a success yesterday. As one of my colleagues said at the Met Office, I wasn't going to let a few thousand miles stop us from running a good interactive session, and with help from Dr. Satyaban and colleagues in the room, I think we made a really good session yesterday with lots of interactive discussion from you all and excellent suggestions. And it shows that both by sharing and listening with each other, we can really learn and improve and continue to make progress where it's needed. And it's been clear to me from the last few days and the excellent presentations and discussions and the hard work that took place during the pre-COF last week, how important that SASCOF is to be held in person, and that the user community is brought into the discussions through the Climate Service User Forum. That's why we've been able to fund this event, because it aligns so well with the UK Foreign and Commonwealth Development Office's Weather and Climate Information Services programme, particularly the Climate Action for a Resilient Asia programme, which aims to support transformational change in the quality, accessibility and the use of climate and weather information at all levels to support sustainable development. And this programme emphasises that this can only be done by working in partnership and collaboration, and this has been showed again and again throughout the last few days at SASCOF. So with that, I'd like to thank the hosts from IMD Pune and from IITM and RHINDS for organising such an excellent event. And I would like to congratulate all of the presenters and the participants for contributing to such an excellent 28th South Asia Climate Outlook Forum. And I look forward to hopefully meeting you all in 3D for the 29th SASCOF. So thank you very much.
Thank you, Dr. Jan. We are thankful to UKMO for their support to organizing this event. And especially would like to thank you waking up early in the morning at 4 o'clock to join our inaugural session, as well as all the interactive session that is happening during the last 3 days. Thank you very much, Dr. Jan. Yeah.
No problem. Thank you, everybody.
And we are fortunate to have received very good support for the SASCOF event since the beginning. And for all the, not only SASCOF, all the various climate services activities from Dr. Rup Kumar Kohli. I would like to request Rup Kumar sir to share his experience or any remarks and suggestions for our SASCOF events.
Thank you, Satyavan. Yeah, in fact, it's a kind of mixed feelings. Having been associated with the SASCOF right from the beginning, I feel like a proud parent, but the challenge is that we have a teenager now. So teenager, as we all know, is the most difficult phase because you have so many dreams and ambitions and you still are learning. So that is where we are now. So in that respect, let me first of all express my gratitude for continuing to be associated with the SASCOF despite my retirement from WMO and being a free man now. But still I feel I really enjoyed this session. And in fact, SASCOF, I think, is moving close to what we actually wanted it to be. In particular, I actually liked the user forum that yesterday and today. We have a rich collection of user experiences and possibilities in the way that we can actually help a better use of weather and climate information for socio-economic benefits. I think this is what actually a regional climate forum can actually accomplish. So in that sense, I think we should now try to move towards an outlook forum to a climate forum. So I hope, of course, on a seasonal scale, we still need SASCOF in terms of the 2 monsoons that we have. But at the same time, I think I support Archana's suggestion earlier that to bring the climate change elements and also climate applications elements into our discussion on a regional scale. So I hope we can actually organize a South Asian climate forum, not tied to anything in real time climate event, but consider general aspects of the climate. And in terms of the SASCOF additional improvements that we can bring, in fact, one of the global ARCOF review meetings that I helped organize many years ago, there was a suggestion to include climate monitoring, that is to actually to see what is happening on a regional scale as of now. So climate monitoring aspects also should be brought out as the essential background for considering the outlook or seasonal forecast for the next season. So that aspect has to be brought in. And in addition to that, there's an area that is still not in the best possible way. That is, when countries go back to their the country representatives go back to their countries and use the regional outlook to prepare their own national level information. So what is the process that is being actually adopted, and what is the experience? I think that should be also part of the national presentations on how, whether they are actually organized in NCOF or whether they have actually modified the forecast that was given here and value added that using some local data. So these are the things that improvements can be discussed here, and then we can actually propose new ways of improving the regional outlook and customizing it to various countries. I think that has to be brought into the discussion. And of course, I also support the capacity development activities. In capacity development, there is also another slight difficulty in the sense that when we bring people from different countries, we get people with different competencies. For some people, the training may be too elementary, or for some people, it may be too advanced, and they are not able to assimilate. So in WMO, there is a competency-based training approach where you bring people of a uniform competency and help them to go to the next level of competency. I think in that sense, the capacity development needs slightly different approach. It sometimes, in fact, that's how it was delinked from the ARCOF session itself. So we can actually go through that process. And finally, I would like to mention that I am working with WMO technical commissions in developing a guidance document for ARCOFs and RCFs, which is actually has taken some shape. We are working on that, and very soon it will be published by WMO, and that can actually help you to bring in more improvements into the session. With that, once again, I thank you and I congratulate the CRS team for the excellent work that they have done. Thank you.
Thank you, sir. Yeah. Now, I would like to request Dr. Ropi Srijit, who is actively engaging with various SASCOF activities and coordinating all the Regional Climate Center Pune activities, to say a few words.
Yeah. Yeah, good afternoon to all. First of all, I would like to thank all the NHMS and other participants from other countries for active involvement in this Outlook Forum meetings. And before that, I would like to comment some capacity building activities. Earlier, we have conducted so many capacity building training associated with the SASCOF in many countries we have. I have visited Bangladesh, Nepal, Bhutan, Sri Lanka. Everywhere we went and trained that CPT and that type of training we have done. But now we have to do again similar exercise, similar process, because many years we have done so many online training, but that is not at all, I think, not effective. For online training, that is many participants suggested that training is not at all effective with this online. Now, last December, we have conducted one training with Python-based training for Sri Lanka. We have conducted from XCast-based, AML-based techniques for very good training material we have already developed for the SASCOF countries. We can we plan for this SASCOF pre-COF we can conduct, but time is too short, and the funding is another issue. This SASCOF also, we have limited funding in the beginning. RIMES support was RIMES was supported the SASCOF. Then that money is not sufficient, but fortunately, Dr. David from UK Met Office suggested he is ready to help for SASCOF session in person. So we got a good amount of support from their side, and Ministry of Earth Science also helped in short time to conduct this session. That is one challenge for getting the physical sessions. But anyway, we can in future we can all these agencies are always ready to help and support the RCC Pune for conducting similar workshop. So the training modules are ready, so we can think about that the capacity building for the SASCOF countries again. And another thing is that this today's morning, that presentation, the impact outlook generation, that also one tool is ready. Dr. Sanjay Srivastava from UNESCO, he suggested he is ready for training for that also. But we didn't get enough time, and there also there are a lot of changes in the person moving into other organization and all. So we didn't get time to for conducting that training also. The next SASCOF, we will try for at least for the AML based training, that XCAST based training we have already done for Sri Lanka, that we can extend to other countries. And another thing is that for the user sector, that is the other training also required. So we have to in the pre-COF as well as the climate service user forum also, we have to have some training for generating that out. That we will in the future we will do. And for this conducting this session, all my colleagues from CRS offices very much engaged in last few months for this one, especially Jose, Raskar and Aarti and Ranjan for supporting that streaming and other all the support we have got from all the my staff and support from head CRS for the conducting this session. So I would like to thank all for this successful completion of the SASCOF session. Thank you.
Thank you, Dr. Srijit. Now I would like to invite Sri K.S. Hosalikar, the head CRS, who is where this our RCC is based, and for his continuous guidance for various SASCOF events as well as climate services activities. Thank you very much.
Yeah, so once again, as Dr. Rup Kumar mentioned, it's a mixed feeling. So as this program is coming to end, of course, we'll have more and more such events. That's a promise that we all keep for each other. But I feel that apart from the science that we have discussed, apart from the technical things that we have discussed, probably this forum has done something fantastic. That, we are emotionally connected with each other. It's a family of South Asia. It's a family where, the South Asia can, come together and, work together and bring out certain things that are required in the region and globally. Recently, the Asia Climate Report was released by WMO. And there are some striking things that have been talked about. The severe weather and hazards that climate related have been pointed out very boldly and very correctly, and with all the inputs from all of you. And they're all facts and the figures, not to be ignored. With that scenario, this type of forum, SASCOF, and the Climate Services User Forum, probably give us an opportunity to come together. First of all, coming together is very important. That's what we feel. Dr. Srijit and myself, for last 4 or 5 months, every day we were talking, Srijit, whether that physical mode proposal has gone, Srijit, whether physical mode proposal has gone. And then once it goes, then there are so many other formalities to be completed. People coming from outside, we require MEA clearance and many other formalities. And yes, we could freeze all of them, in time, just in time, I can say. And a lot of efforts by Srijit and his entire team. So really, Srijit, you have done a wonderful job. I should congratulate you personally. Apart from that, let me go to the higher ones. I should thank Ministry of Earth Science, Secretary Ministry of Earth Science, Dr. Mahapatra, our headquarter, DGIMD, and the UK Met Office, WMO, RIMES, and all other participants who have been connected with us right from the beginning. We have been very lucky to have this type of very resourceful person coming here and, delivering in at the exact time when it is required. So many good talks that we could hear. There are a lot of learning for all of us. And this was really possible because of the very strong support by these big agencies like RIMES and UK Met Office and WMO and many other agencies. I should thank my colleague from JMA also, who is here. And indeed, otherwise, we all at Punekars, we are always there. We got very good support from all of you. Bhutan is there, Pakistan is there, Afghanistan is there, Bangladesh, Sri Lanka, Maldives, all these countries who have been here wonderfully participated. We had wonderful discussions. Couple of points before I end my this thing. So this Pune CRS office or IMD Pune office is, as you know, that it's a regional climate center. It has few more credentials. It is the regional training center at WMO. It's a regional radiation center at WMO, so that I will know. And recently, Ministry of Earth Science has approved a proposal for making this Pune as a regional instrument center also, RIC. And this proposal has been was submitted to the last RA2 meeting in Beijing. They have approved it. Now the WMO has to give the final concurrence, and certain things are happening. Why I'm mentioning this? Because this will probably help all our South Asian countries, Maldives, Sri Lanka, and many other countries, neighboring countries, to do the further hand-holding as far as the meteorological instrumentations are concerned. The training is concerned, the calibration part is concerned. You don't have to depend upon, the OEMs for that. Probably we have all that capabilities and capacity to do that. We can conduct the capacity building training also for all of you. Just give us some time. It's already in the process. Probably we should be able to do it in sometimes ahead. This is one part. And second, as Dr. Srijit mentioned, we should conduct the CPD training, sometimes before monsoon if it is possible. Let it be online. I know it's not very effective, you said, but some of the colleagues mentioned that they need to have this type of training. So maybe if possible, we can think of it if we can conduct at least half day or something. Or somebody who wants, we can, requirement basis also, we can think of it. And many of them expressed that this should be in physical mode for different SASCOFs. Yeah, we also want this to happen, but definitely there are many other logistics things to work out, and let us see how best we can do it. But at least this monsoon SASCOF should be in physical mode, and it should continue. It stopped somewhere around 2016 or 17. I'm not very sure, but maybe we should continue with this. I should thank my wonderful CRS team who are sitting there on the back side, but they have really worked very hard for last more than a month. And I'm very lucky that, I'm a part of this entire team. So congratulations and appreciations to all of you for that. At the same time, there are my colleagues from IITM, there are my friends from the IMD Delhi office and other offices from the IMD, and my friend Dakore from Agriculture University, Marathwada, and there are many other to whom I could interact with them. My friend here is there, some of my former friends, Arvind, Pulak, they're all experts in the field. I'm happy that they could be here and they could participate and contribute. Last but not the least, maybe you are seeing somebody standing on the dais, Dr. Satyaban. So he's something, something very special, I can say. And you might have seen him, running around and, doing all the technical as well as logistic things. So really, I'm very lucky to have this type of people around, and this type of thing, motivate me that, और भी check करना चाहिए. We should move, we should do more and more things. And before I end my speech, I should not forget my friend Dr. Rup Kumar, without whose guidance, probably we would not have moved to this level. So, Dr. Rup Kumar, really we are very thankful to you, and we are very lucky to have in Pune CRS and climate related group. So there's something very special for all of us. So once again, I congratulate all of you for this wonderful 3-day session. And before I end my speech, I will wish that let this 2024 monsoon be good for entire South Asia, and may all of us flourish, and no very severe weather also expected, but they will come. But okay, we will have some mitigation. We have people from NDRF to help you, so don't worry about it. So thank you very much. And if you are going today or traveling back to your respective countries, I wish you a safe journey, and we'll remain connected. It's a South Asian family. That's I call it as. Thank you very much.
Thank you, sir. Now I invite Ms. Aarti Vandgar to propose a vote of thanks. Thank you.
Thank you, Dr. Satyaban. So before starting my vote of thanks, we should thank Dr. Satyaban for nicely moderating the day, because there were changes in the agenda, but he could manage and coordinate with all, and we have a very good discussions. So it is my absolute pleasure to present vote of thanks today. We were here for last 3 days for the 20th session of Seasonal Climate Outlook and Climate Services User Forum. And now we have come to this end of this event. I know that our foreign participants are eager to visit our IMD office. So quickly I will finish my vote of thanks. First of all, I would like to thank Ministry of Earth Sciences, Government of India for their support. I extend my thanks to UKMET office and RIMES for their consistent support and cooperation for conducting the event. I thank all the NMHS participants and delegates present here for the event in physical as well as online mode, and presenting their country perspectives for the preparation of seasonal climate forum statement. Also, I am really very happy to thank all our eminent speakers who have participated online as well as offline, and they have shared their valuable research and their views with the participants, and I am thankful to each and every one of them. Also, I would like to thank our session, all the session chairs and rapporteurs for nicely managing the sessions, and moderators. Now, I take this opportunity to thank respected DGM Sir IMD for his guidance, and I sincerely thank our head CRS, Dr. Hosalika Sir, for always encouraging us in so many ways. And now I thank sincerely to my mentor and my guide, head CMPG, Dr. Srijit, for his continuous efforts and support to conduct the event. Last but not the least, I thank my RCC IMD colleagues who are always being very much supportive for the preparation of this event, and they have been very much patient while while doing all the preparations for the event. I thank all our volunteers team members for the successful conduction of event, and I also thank our audiovisual team for being there and given some technical support. And I am indeed really very much thankful for each and everyone who has supported this event happening successfully in some or other ways. I kindly apologize if I have missed someone's name. Yes. Yes, I really thank this hotel management team and providing such a good ambience and good hall for the presentations and event. And thank you all once again. We will now, after tea, we will proceed for tea, and after that, I request all the NMHS and foreign participants, RIMES, and we should gather at a place, and Mr. Jose and my colleague Mr. Raskar will coordinate with them for our next visit. Thank you so much. Jai Hind, Jai Maharashtra. One announcement for our volunteers. Kindly do come forward. We will have one group photo. All our volunteers from RCC IMD. Yes, yes.
SASCOF declaration for preparing marriage.
Okay.